We are live.
So we thought about moving the camera even, maybe put it over here so that you see not the audience, because the audience is not so interesting.
Yeah, of course.
What is there on the screen and the speaker?
Yes, that's okay. We can move.
So the question is, can we take the whole table?
Yes, what table will you can? That's only. Let me disconnect this because I think we were not using this one.
Right.
Okay, so disconnect it. Flashing a really expensive camera.
It's from the office.
Take the table. Come on. Wait a moment, the power.
I think, yeah. You need to disconnect the power. Where do we need to go?
Yeah, near. Let's move that. Wait a minute.
Achso, wir können nicht gehen ohne ihn oder sonst irgendwas. Oh.
Okay, here is fine.
Oh, we take it from over there.
Yeah, of course.
Director's chair.
Okay. The microphone is working. So I don't know if someone will ever see what we are doing.
Okay, and this is
Fine.
Then you can stand here and talk. Right?
Yeah, fine. Yeah, they can even see the screen. Okay, can you check if you are getting the 4K streaming? This is working?
Power and password. Oh. No. Das wo das Stream ankommt?
Dario, due cose. Mi senti? Allora, abbiamo rubato un po' di quei teli che ci stanno tipo arancioni dentro la scatola da mettere sui lati. Ho detto che possono tirare. Sì, li stiamo usando, volevo solo dire questo, volevo la conferma. E poi ti volevo chiedere se avevi un jack out da piccola a grande, perché abbiamo i microfoni, volevo collegare la cassa che ci hai dato, ma per farlo devo collegarlo a un jack piccolo grande.
Oppure un cavo.
No, c'è i microfoni che si collegano al computer, c'è sempre solo il jack piccolo grande per collegare le casse là. No, i microfoni sono wireless collegati col cellulare, capito? Semplicemente grande, esattamente, cioè io collego la cassa il grande, il piccolo a quello che c'è nel microfono in maniera che...
Maschio piccolo,
maschio
piccolo, femmina grande.
No, maschio grande, maschio piccolo.
Il cavo quindi il cavo
no, io qui c'ho
la femmina è piccola.
La femmina che ci abbiamo da collegare è piccola e poi abbiamo una femmina grande dentro la cassa, quindi servono due maschi, uno grande e uno piccolo.
E poi lì pure se c'ha.
Wann kommt der Albert ins Bild?
Non è un cavo, è un dispositivo wireless.
È un dangle.
È un dangle wireless. Sì, quelli piccolini.
Dove sei?
Che va dentro. Quindi mi serve.
Ja, weiter nach unten würde ich sagen.
Esattamente.
Poi gli chiedi pure se c'hai i piedi del televisore.
Grazie.
I piedi del televisore.
Cosa? Scusa. Senti, c'è un attimo Gentini che caga il cazzo, te lo posso passare prima che gli do una pizza?
The gold?
Yeah.
Oh, da?
It's fine. What is this, the resolution?
This is now
HD?
this one.
No, it's not going to
You're
4K.
not satisfied with Full HD?
No, it's not 4K.
You need 4K.
It's streaming 4K.
Yeah.
You see? It's 4K? But 100p will be fine.
I'm happy.
Quello che è importante è la persona, però che te sai che non abbiamo. Cioè quello che sta sullo schermo comodo, che è un po' di fare.
No, first time.
On the screen?
On the screen. People lost.
3 minuti e 40 per...
I'll go and rescue Maurice. And put some signs. But the way to do it nowadays is sollen wir einfach noch aufnehmen mit der Kamera, dass wir aufnehmen?
Als backup?
Try now if you're getting the 4K option. Not yet.
To stream to YouTube in 4K, here are your best settings. Go to the settings tab down in the bottom right hand corner. This is going to be a combination of the official YouTube recommended settings for this plus my own from 15 years of experience doing professional broadcasting. All right. 30. The base canvas resolution is the output understand option, which is this. If you don't, by the way, I have a link to your frame rate. It's content like this, 30 frames of play or will at hit rate. Select 44.1 kilohertz. Recommend 0.1. Make 4.1 $4.5 million. This and make it advanced. That's going to unlock everything that you see here. I do not recommend.
Yeah, one nice long HDMI cable is missing. Nein, das reicht nicht. Dann müssen wir das Ding zur anderen Seite umstellen. Das ist schlecht.
Check. Ah, this works. Nice.
Yeah, that's good.
Nice. With echo. Hello.
He's a bit powerful.
Can anybody?
Nice. Okay.
What is this?
I bring it for the 4K.
Audio?
Yeah, exactly. Because no, it's an i9 12 core plus
Does it work? Does it work?
270 Ti.
Work. Check. Okay. This seems to work. Opening ceremony.
Ist es dein Kopfhörer oder haben wir den Mixer?
No. I turned off the audio for the streaming.
Ah, okay.
Try now. Try.
Then it makes sense.
Hello, audience.
No, from the microphone. The road.
Ah, from the road, okay. Is it mono? Is it stereo? Is it a microphone? Is it a plane? Is it Superman? Is it Batman? Is it Batcave? No, nothing yet.
Working.
Is it working on your end? No.
Yeah, streaming.
So
No, it's normal. It's streaming. There is all this. Okay. Okay, started the streaming.
So
Try now.
do you see the levels on your machine? Is it in stereo? When okay, so here it is correct. Okay, good.
Here is out. There is out. You see?
Okay.
Now it works.
Yes.
Yeah,
Yes.
the problem was the stereo. With the stereo.
Ah. Okay. Okay. Good.
Sometimes there is a problem. But even the cable you will fix it. What they can do is this.
Or you don't use the PA at all because the audience is going to be.
Yeah, when they're chatting.
Okay, I've started balancing the Battlemesh wireless to different things.
This is kind of suboptimal.
Das ist noch unschön, ne? Also hier. Also zu steil, oder?
Prinzipiell geht's. Only if the guys have the right side.
Naja, aber wir sind halt da.
Okay.
Darüber?
Shit.
Sì?
Wir könnten es nochmal ausfädeln und versuchen, dass es geändert wird.
No, io ho detto a voce. Che? Poi? Giorgia? Giorgia?
Talk about doing it
No, no, don't worry.
one round and then
Disconnect that.
okay. So I think the only thing that we can barely use the table. Or we switch the tables to the other side. Then it's not enough.
Okay, each
So this is a 2 meter.
I have one for the someone has a mini HDMI.
We don't have it to the spare. We have this one.
Scheint halt trocken, so der Wasch. Das wird trocken. Ja, ja. Das wird gesehen unter 2 Jahren. Ja.
Also ich glaube, wir drüber geredet haben, ob das eine so eine stabile Adresse ist und so. Und so weiter. Ja, das ist.
Okay.
Die Adresse hat sich noch nicht geändert. Und, behind the scenes und so. Irgendeine Frau am Start und auf der PHP jetzt nicht drauf, weil ist aber ich habe das weiß von der Last
Nicht wirklich. Alex Genie.
Näheres kann man plus minus auf der Karte sehen, aber also ja.
No, come on. So what do we have? Yeah, okay. So this is a map of all the non-profits we have in France, basically. Yeah. So mostly the blue ones are the more active. And what's interesting is that we all very different. And
Use the microphone.
sorry? Are you streaming this? Really?
Yeah.
Completely improvised, but and what's interesting is that we are all very different. I mean, so the one I moved, but I was in this non-profit one, and we do this wireless thing connected to this dedicated fiber network and so on. So there's the one in Lyon, and we share the infrastructure I showed you before. Yeah, and we have one POP in one data center here and in one data center here. So it makes sense to, I mean, it's not very far away and we get redundancy. So it makes sense to work together. And then these guys in Toulouse, they have the biggest wireless network basically. They started 10 years ago and they have antennas everywhere. And they do also some hosting. So you can bring your NUC or laptop or whatever and put it in a place where they have very good connectivity. Yeah, so different things. Let me go quickly. Yeah, okay, I already showed you this, but this is the main place where we are located. Yeah, and our infra is only three machines, and the same in the other location. And we have one router. It's just running Debian, and then we use Bird to connect to our transit providers. This runs virtual machines. And this allows us, it's a big switch that allows us to connect to other operators, the internet exchange, the dedicated link we have to the other location that we lease and so on. Yeah. I also show you this, but this is the main location where we, the main wireless location, where basically we see the whole city, and we have. But then it means that each client, let's say, it's only connected to one access point. So if the access point breaks, then it breaks for the client also. So for us, it was simpler to do this, but you could imagine that doing mesh on this area could help if there is an outage, so you could find another path. I think there was somebody from New York City Mesh in Paris, and basically they have the same kind of infrastructure where you have the main network with access point and clients, but then they also do mesh networks in this area. So they prefer to use better link if available, but otherwise they will do a lot of hops on on omnidirectional antennas and so on, which is less performant, but if it works, then you. I mean, if you don't have anything else, they will use this. But we don't do that.
Because it's too complicated.
Yeah. Yeah, okay, so it's the same thing, but with just a roadmap. We have this backbone. This is 2 data centers. And so this is a bit also, these were just tunnels on whatever fiber connectivity we could find. And now we have a dedicated fiber from this location to this location. Yeah. And this is a wireless point-to-point link. And here we have a lot of access points and clients. Okay, so this is another network in Bourgogne. So it's not very far from Paris. And so now I think this is the biggest network we have in France. It's less organized, let's say, but they have mostly this central location, and then they do long point-to-point links to very rural areas where you don't have a lot of connectivity, and then they dispatch the access in each area. Yeah. And they have a few hundred, maybe 500 people connected to this. I don't know. Yeah. And maybe one difference with maybe Frankfurt, for instance, I'm not sure, is that for all these people, it's their main connectivity. Yeah, it's like your internet access. So yeah.
Donation based?
Sorry?
Donation based? They pay subscriber fees?
It depends. So for us in Grenoble, yeah, you have a subscription, and it's like 15 euros per month that you have to pay. So it's really like you would get an ISP contract, a contract with an ISP. It's just that the ISP is a non-profit organization. And Scani, I think you have to become a member. So you take actually everybody in Scani, everybody is a shareholder of the non-profit. So you pay 10 euro and you become one of the shareholders of the structure. And then you pay every month for the service also. Yeah, okay, it's the same. Well, on the technical part, I'm not exactly sure what they do, but they have several areas, and they connect the areas between. They do some connection between the areas. And I think each area is a big layer 2 network from what I understand. But again, they don't do any mesh in it. It's just a big tree with a lot of devices. Okay, so cool. I have it. So this was our first dedicated fiber. So we did this because there was a Wikipedia event in France. So from time to time, the French Wikipedia community, Wikimedia actually, community goes to a place to have a conference. And so it was in our city, and they said, "Oh, can you provide internet?" So we said, "Cool, we have a fiber project, so let's." So if you have, so we told them, "Oh, if you have 1,000 euro, we can provide connectivity." Say, "Oh, okay." And so this was the first. So as I explained to some people already, in Grenoble there is a municipal network that is built by the city. So they deploy fiber cables around the city. And at first it was mostly for their own needs, to connect the schools, to connect the all public services. But then, I mean, when you deploy fiber, you deploy cables with a lot of fiber actually. So a lot of it was not used. And so some people in our session, they told them, "Oh, you have to open the network and sell some of the fibers or lease some of the fibers that are not used." And after several years, they agreed to do that. So now any operator can lease fibers from the city and use it to connect some places. But it's dark fiber. So, I mean, they only provide physical connectivity between two locations that you ask them. And then you have to put some equipment to light the fiber and so on. So it's not a managed service, it's really infrastructure. And do we have a map? No. Okay, so this is not our network. This is a network from the city. Okay. And basically, they deploy cables every time they had to open the roads and this kind of thing. Like when, like we have a tramway, and every tramway line there is some fiber underneath. And basically, so we are located in a data center somewhere here. Our main radio location is here. We have also other locations, and so we can ask them, okay, we want one fiber from this location to this location, and then they will find a path across the cables. They will do the splicing in when you change cable, because you have to connect on the optical layers the different cables. And if needed, they will do some like dig the ground or add a bit of fiber, or add some cables to go to the location we ask them.
At a cost?
At a cost, of course. but so basically, you pay upfront the digging part, so it can go from 0 to 10,000 euros, depends. And then you pay a fee every year for to lease the fibers. And basically, the cost depends on the distance. So the longer fiber you want, the more you would pay.
How many inhabitants does this area have? How many inhabitants does this area have?
Oh, in Grenoble, 200,000 people, I think. Yeah. And basically, yeah, I don't have a. Yeah, I don't have a picture, but basically, in the end, what you get is that in the building you wanted to have connectivity, they install. Sorry. A patch panel, exactly. Where so actually they deploy 12 fibers each time you ask them, because somebody else could use the same network on the same building. And then you have the patch panel, and they tell you, okay, you can use these 2 fibers, and you connect something here, do the same thing on the other side, and you have a link. So, yeah. Yeah. So this one, was the first time we did this for the event. And then we did the same in this central location where we have most of of the people connected. And the fun thing is that so there is a cable car that goes to this location, and yeah, because the fiber network does not go on top of this area, but we wanted really to have fiber coming here because it's the main location. But there is a cable car that is also managed by a public entity. And they had some fiber to connect the place below and the place above of the cable car. And because they needed to have some security thing to be able to stop the cable car from below and so on. And so they had a fiber cable for this, and we managed to get one fiber on this cable. So basically, we use the city network in the city, and then the one fiber from the cable car to connect this location. And all of this takes time. Each time you have to discuss. Yeah. Yeah, that's it. Ooh, thank you. Yeah. Anybody ask questions or wants to present something? Plain OSPF.
And what happens if you have packet loss on those links?
Well, you have packet loss, I mean. But yeah, we don't run OSPF on all the links, as you understood. So it's only a few sets of dedicated point-to-point links, so it's mostly reliable.
I always heard that OSPF is not so good dealing with packet loss, but maybe I'm also wrong.
Well, the thing is, it works even if you have some packet loss, But then the issue is that it will not really detect the packet loss. So it will still say, the metric is fixed. That's one difference with OLSR or Babel, for instance. So if you have a bad link that loses a lot of packets, OSPF will still say, oh, this is the best path. And so all your traffic will get packet loss. Yeah. So, but since we manage all the links, it's not really a problem for us. Yeah.
Question. Do you deal with the noise in some specific way? Because it looks like a very densely populated area with a lot of RF noise. Do you deal it with some...
No, it's really annoying because there's... we use 5 GHz mostly. And maybe 8 years ago it was nice. There was not much users on this band. But now every box, every router does uses 5 GHz. So we get a lot of interferences, yes.
Okay. It looks like a project that has some resources. So did you think to buy some antennas on other frequency bands? Like higher frequency bands, noise,
So we do have some 60 GHz links, but so 60 GHz, we don't use it to connect people. We use it for point-to-point links for the backbone, and it works quite well. Yeah, but it only works for short links.
Okay.
Yeah.
Short links like kilometers or
2 kilometers. 2 is already a lot.
Okay.
And when we want to align the antennas, it's really hard when you have 2 kilometers. Yeah. Okay.
Another question was the power that you use for the 5 gigahertz, right?
Yeah.
Like I suppose that you use the maximum legally allowed power for the 5 gigahertz. Yes.
And that is?
So for the power in France, it may be different in other countries. It's 1 watt of equivalent. Yeah.
Okay. And what kind of people use this network?
You mean the people that are connected to the
Si.
network? Yeah. So at first it was mostly geeky, tech people. But actually now anybody basically. So we have time every month, I think, or twice a month, where people can come and discuss and say, oh, I'm interested to be connected to the network. And then some volunteers from the association will go to their place and install antennas and so on. But anybody can connect.
I can understand what kind of place. This is a room, public place, is a house?
You mean the place where people can come and discuss?
Yes.
So we don't have a building for the project, but we have a lot of other non-profits, like a hackerspace, like there's a kind of a social center.
Something like this, Fuxjäger.
Yeah, like this place. And once a month we can take the space and receive people.
And there's no houses.
What do you mean?
Families, people, normal people connected continuously to the network.
No, this kind of place is where we host kind of events where people can come to discuss, but then anybody can connect. There are families connected.
Okay, but not houses of that families.
Yes, we connect the houses.
Okay.
Yeah.
Dice que sí hay casas de familia.
Yeah.
Okay.
Most of the people connected to the network, they are just like regular people in an apartment or house. And
And they pay a subscription.
they pay a subscription, yes.
Okay, and
So it's really like a regular ISP, the same kind of contract and service, but it's a non-profit.
¿Qué clase social?
Social class. Like which, I don't know if you can see that, but which social class are the people the users from? Is that the question?
Yeah. I think we have a bit of all classes. Because the kind of people that are interested in this project and they want to get connected. So you have some people that are interested because it's they don't really trust the big ISPs. Some come because it's cheaper. Because actually, so we don't have to pay people to do things, so it's in the end it's cheaper. But of course, it needs volunteers. So, but for some people, they really come because otherwise it would be too expensive to have a regular ISP connection. Yeah.
Okay. And the people who work at the network, vos me corregís si yo digo algo. Is all like us at the same age? Maybe there is the teenagers from university students.
You mean the volunteers that are making it work and so on? Yes. So at the beginning, it was mostly people in computer science and so on, or engineers. Now we have more people. We don't have really teenagers or something. We have people at university. I mean, people studying at universities or schools, engineering schools. We have a few retired people. They have some time and they help. Yeah, that's it.
Okay.
Yeah.
How many clients are connected to this point approximately, to this central point?
But a bit less than 100, I think.
Okay.
I would say maybe 80 people.
Okay, that much. Okay.
But now we have a kind of a problem because at first we were growing, but now just managing what already exists takes time, and we don't have time to add more people. So maybe we will start paying people to do things. I don't know. Because since it's the main connectivity for people, if it breaks, you have to fix it and not wait 2 months to fix it. So we spend a lot of time to fix existing things. Yeah.
Do you have a monitoring for the clients when you see they are not connected?
So we have monitoring for the main infrastructure, and for the client it's difficult because some people shut down everything
overnight,
at night, and then so now we don't monitor it. Okay. I mean, we monitor it, but we don't look at it, let's say. But people complain, so yeah.
Okay.
Yeah.
So you showed some data centers, and you said you have directly a fiber between them. And isn't that very costly? So like having a dark fiber between 2 data centers? So I think it's around 500 euros or more.
It depends on the distance.
Okay.
But actually, it's in the same city, so like I showed, the data center is here, our main location is here, and there's no scale, but it's a few kilometers.
Okay, this is not so okay. And where do you get your transit or uplink connectivity? Are you like connected to an IXP or?
We are connected to an IXP, yes.
Okay, and you do a BGP peering. Okay.
Yeah, and we have 3 transit providers, I think. Let me show you.
But do you get some kind of sponsoring from their transit providers, or?
So at the beginning, we had some sponsoring. But as we grew, we have more money, so now we can pay the real price.
How much do you pay?
So let me show you first the infra, and then. So as I said, we have locations in 2 data centers in these 2 cities. Then we lease a layer 2 links between the 2, where we can have our own VLANs and so on. And then we have 3 transit providers here. So I'm not sure you know these companies. These are French companies. Yellow Liaison. IPMax is a Swiss company, but it has an infrastructure in Lyon. And Jaguar is also a French company. And this is Internet Exchange IXP in Lyon.
And is that 10G or 1G.
Most is 10 gig, yes. And this thing is only 1 gig because it would be too expensive otherwise. And we have kind of the same thing here, but only 2, and no AXP. And then this is a dark fiber network that we connect to this location. And we have other services. We have DSL. We have some FTTH connectivity, but we don't. I mean, this is all infrastructure that we don't manage ourselves. We just buy it to another operator. But this really is our own infrastructure. And the overall cost, it's around 15,000 euros every year. And to give you an idea of, I don't know, a transit like this, when you have a few hundred megabits per second, it would be 200 euros every month, kind of the price. Yeah, each link or transit provider costs, let's say, €1 per megabit per second on average. You pay for the capacity, not for the. And to be able to pay for this, I only show the network part, the wireless and fiber network here. But there are other non-profits that use the same infrastructure. And we share all this. Like in Lyon, they also do some, so they do some FTTH and DSL. There is another non-profit that does hosting. So you can put your server in their location and so on. And we all share the cost of this.
Yeah, you already said that for the few volunteers you have, you already have a lot of work with this, and I would be interested, what is the kind of work you have to do, and what are the biggest time consumers you have? Is it mostly like some hardware breaks, or is it you have to do some social or some support because maybe it's just a Windows bug or something on the laptop, or what are the issues that you have to work with?
So basically, the interesting thing is that this kind of infrastructure, it looks complex and so on. I mean, on the technical level, it's a bit difficult, but once it's done, I mean, it doesn't require a lot of time. I mean, this BGP connectivity, we set them up like 6 or more years ago, and it just works. So, and power, I mean, when you are in a data center, power is very reliable. So, basically, we buy a machine, we install it, and then 6 or 7 years later, we change it, and it never reboots in the middle. So it's completely very, very stable. And most of the time is actually on the wireless part, because wireless is not that reliable, as you know. And so there's one part which is really user support. Like somebody tells you, oh, it doesn't work anymore, then you have to troubleshoot what exactly is not working. Sometimes it's just the cat played with the cables and it got unplugged. I mean, yeah, that's. Or the people who installed it did not correctly clip the Ethernet cable, something like this. Sometimes you have wind and the antenna moves, then it doesn't work that well, of course. So you have to go back to the place of the people and move the antenna back. And sometimes we teach people to do it themselves, because otherwise it takes too much time. Interferences is really annoying, because you install it, it works, and then 6 months later it's really shitty because somebody else using the same frequency in the same location. So then you have to try to change the frequencies and so on. This takes some time. Yeah, this is a kind of thing.
Would you also have some kind of wish list of software which would solve your problems, or which would cause you less work? I don't know, you said like mesh is not used so much in your network at the moment, or could it be helpful for with the interference automatically switch or something? Do you have less work, or?
I don't know, frankly. Because the way we do it, it's more like we manage most of the infrastructure. So maybe if part of the infrastructure was managed by local people, it will be easier. Yeah. Actually, we have something like this. There's one place where there's a building with a lot of apartments, and I think 3/4 of the apartments are connected to the network. And we put one antenna on the roof, and then we have switches in the building, and everybody gets connected to the same antenna. And when something breaks in the building, they fix it themselves. I mean, so I think it's so maybe on the software side there will be something to do, but I think it's more a social thing yeah.
With this connection of multiple tenants in one building, how do you do it with the powering? Do you use power for multiple ones, or do you make an arrangement with the building facility also?
So we try to make sure that it does not depend on one single person. It's not always possible, but when there are several people in the same building that are connected, then it's easier to go to the say that in
building owner or
building owner or building manager to say, oh, we want to take some power.
Okay.
That does not depend on each apartment, but that it's for the building. And usually it's not a problem because the power is very low. Like we consume maybe 10 watts.
Yeah.
And they say, oh, okay, 10 watts, we don't even make you pay. I mean, it would be more work to make you pay than the cost of electricity.
Exactly. When you make an extra meter just for that, it costs
exactly.
you much more.
So in some cases, people are stupid and they don't want, or it's difficult. But most of the time, they say, oh, just use this plug and it's okay. Yeah. And actually, we discovered that so when we cannot do this, we managed to get two PO input to the same switch, and it kind of works, actually. I don't remember if it's microtic switches or ubiquity switches, but you can actually power it from 2 ports, and you can disconnect any of these, and it continues to work. So that's
for microtic, there are new ones which are called RB5009, which are especially for this purpose, that you can have power from 8 different ports simultaneously.
Oh, okay, cool.
And the highest voltage wins and puts the power in.
Okay. But for the hardware we use, it's not specified that you can do it. But
it is specified.
No, but for the hardware we use,
yeah.
I don't know the kind of hardware you are talking about. But the one we use, it's not specified that you can. But we just try and it works. So.
Yeah, we have the same with the Edge Router XSFP. It also works with multiple inputs.
Okay.
Yeah, because of the bypass diodes.
Of the?
Bypass diodes. When the voltage would be too high, that it's clamped to the bus voltage of the system.
Okay.
And these diodes allow reverse flow.
Okay. Cool.
Yeah. So how do you organize? You said like you're a group of volunteers, and you said it's also a lot of work to do the support and whatever. So do you have like kind of structure or like different roles you fill, or how do you make sure that always somebody's available to take care of that?
Well, there's not always somebody available.
Okay.
I mean, that's part of the issue why we cannot have more nodes, because already now sometimes it's broken for people for 1 month, and we don't have anybody to fix it, so it's not that good. And also because it's a city, so you start to have FTTH everywhere. So we are trying to move to this kind of infrastructure instead of doing wireless. But to answer your question, so we have monthly meetings where all active people participate, and that's why we take decisions. So we recap what happened in the last month, and then we take decisions. We can be technical decisions on a high level, or just I don't know, decision about money, about should we participate in this event or not, something like this. And then we have groups that are dedicated to different things. Like one group for communication that does flyers, website, whatever. One group for the wireless network. One group for the core infrastructure, all the services and so on. Yeah, that's
You
it.
said New York City Mesh. Sorry, you said NYC Mesh came to visit. What are they doing? Because I know they do. It's donation based as well. It's like $20 a month, something like that, up to 40. But are they paying normal like techies to come out? I know that the installs are volunteer. The person getting installed, they are the ones that pay for the volunteer's time. But in terms of like network maintenance and monitoring, is that coming out of the donations?
I don't know.
Okay, I just figured.
I just met these people 3 years ago, so.
Got it.
But it seems kind of similar to what we do. And actually, we are also debating. The first problem we had was to connect new people, okay? Because at the beginning we were maybe 5 or 6 people motivated to do installation, bring the antenna. Then we were less available and do some other things and so on. So we tried to have new people to help, but it's not always easy. And in the meantime, many people were interested to be connected. So we started to have a waiting list, which grew a lot. And people will wait 1 year to get connected. So again, not very good. And the first idea was to say, to do the initial installation, we will pay people. Like take, people that know how to install antennas. Like it's their job and we can pay them to do this. We did it a few times, but actually we realized after that support is also takes a lot of time, and you cannot just pay somebody once to fix it. It's more complicated. So that's why we stopped growing a bit, mostly because of support. And we are thinking about maybe changing the structure to be able to actually employ somebody to do the support. Just not one shot. It's really somebody that works for the structure to do support. But it's not yet.
You mean somebody of the volunteers or somebody external?
Maybe some of the volunteers, or maybe
One thing that we're talking about in South Africa is there's about 5 different community networks sharing one resource that can remotely log in and see where things are messed up in Unify or whatever systems that they have. So we would pool our resources and have one super nerd be able to wire guard in when shit hits the fan. But it hasn't happened yet, but hopefully soon.
Yeah, okay.
Maybe one of you guys can help us out.
Yeah, you talk a lot about switches, but what about routers? So, for example, here, is there a router, or do you just layer 2 bridge everything to somewhere else? And and another question would be, how much free software like OpenWT do you use, and how much proprietary stuff?
So on each location where we distribute the network, where we have access points. So this is the biggest one, but we have maybe 5 sites, I guess. We have one router, and it runs Debian. And this is only using free software. So again, we use Bird to do SPF, WireGuard. No, not WireGuard, but the Bird. We have a DHCP server. We use Key. It's the new DHCP server from ISC. And then we plug this to a Radius server, which is running FreeRadius. I mean, most of the core infra, so servers and these routers, it runs Debian and it's all free software. But then all the antennas, we keep the stock firmware. So it's mostly Ubiquiti, a bit of MikroTik. But this is only doing layer 2. So basically, our approach is to say we want to control the routing part and the layer 3 part. So this router and each subscriber has a home router that we provide. Well, if somebody wants to use its own home router, they can. But by default, we provide one, and this is running OpenWRT. So basically, layer 3 between the subscriber and our router is all free software. But then in the middle, the layer 2 stuff is proprietary. That's our compromise. Yeah. And mostly for security reasons, all this equipment, they don't have access to the internet. Okay. It's only internal, and we have this ubiquity controller, UNMS. I think it changed names, but
USB is the new one.
yeah, yeah, to manage all this, but it's really isolated and doesn't have access to the internet. Yeah. So basically, it's a compromise, let's say. Okay, another one.
Coming back to the question somebody asked, like about your wish list. What would you have in the wish list for substituting the AROS? No, is it AROS? The Ubiquiti proprietary software with OpenWRT. What's missing in OpenWRT in order to replace it? Like the EFS is good enough or stuff like that?
So basically, the thing is that either you keep the stock firmware on all devices or use OpenWRT on all devices, but you cannot mix the two, which is makes things difficult. And basically, we looked a bit at it, but we expect to have better performance and more stable links on the stock firmware, which may or may not be true now, but when we started, it was really the case. So we said, okay, we have enough problems on the subscriber side to not have also problems on the access points. So right now, the access points, it's mostly stable. And if it doesn't work, you just reboot them and that's it. But we don't have really to manage to build our own firmware for it and so on. We do this work of building our firmware for the home routers, but that's it.
Okay.
So it's, for us, we don't plan to move that to OpenWRT or not. It's,
sure. Yes. Another question: if you have left like over more money that you need for managing the infrastructure, do you use them for sending people to conferences or like?
No, but basically, we use it to. So we use it in mostly two ways, not for paying people. Or going to conferences. But so the first one is to replicate this kind of project in the countryside around the city, because I mean, it's not the same needs, because here we're in a city, so if you want to have good connectivity, you have DSL, fiber, and so on. So you don't really need our infrastructure on the technical aspect to get connectivity. People do it because they are interested in the political project or because it's cheaper, but not really because they need connectivity in the first place. Well, in the countryside, in some places, there's just no connectivity or very bad connectivity. Yes. And so people came to see us and say, your network looks nice, can you do the same in our village? And what we do is that we help them to build the same thing in their village. So we don't go to the village to do everything, but we teach them and help them to set up. So part of the money goes to this. Because at the beginning you have to buy hardware, so it costs money. But then in the long term, it will be profitable, let's say. But to start with, it's nice to have already some money to get started.
Okay, thanks.
And the other thing is new projects, like what could I show? Yeah, this FTTH thing. Sorry?
On the right, on the top?
Yeah, this one also and this one. So basically, so what we do is still small, I mean, and the region, let's say, I mean, in France, the public authority try to also deploy FTTH everywhere, okay? And they have quite a lot of money for this. And often they pay a private company to deploy the fiber and operate it. And we managed to get a contract with this kind of company so that we have one link to their network and we can have subscribers everywhere in the region. and we don't have to actually connect anything. They do everything for us, and we get the traffic from the subscriber in our data center. And to set this up, it was a bit expensive. I think it was 5,000 euros just to set up a link. Kind of expensive, but anyway. And so for this kind of project, if you have already some money, I mean 5,000 euro, if you start, it's kind of expensive. But for us now, it's not that much. I won't say it's nothing. That's not true, but we can afford it.
Very nice.
Yeah. And if you want to test new hardware, you can just buy 10 different devices and try to port OpenURT on it or anything. So, yeah. And if we start paying people, then it would be good to have some money. Yeah.
And for the dark fiber, which the municipal put out, did they finance it from their own budget, or do they also get funding from the state of France or from the EU or something? Or?
So for the municipal network, we are using
the dark fiber, which you are leasing. Yeah.
So it's completely different from this. Just to be clear, this is really FTTH network to connect every house in the whole of France, while this is really dark fiber for operators. So. Just to make clear that it's completely different.
Yep.
And this one, I don't think there is any money from the government.
Okay.
It's basically they deploy it for their own needs, so they pay for it.
Okay.
And since now you can lease fiber from them, we help them to build this network, let's say.
Okay. And do you get any fundings from like EU or something, or is any?
No.
Just from your subscribers?
Yeah,
or?
just subscribers.
Okay.
We don't want to depend on subsidies.
Okay.
Because then, I mean, if you want to, so here it was okay, but if you want to criticize the public administration, we can do it because we don't get any money from them. Otherwise, it will be more difficult.
Yeah.
Like this is managed quite badly. And so we criticize them, and so yeah, and we can do it.
What is the utilization of your transit links to the internet?
Oh, it's low.
Okay, because
I mean this. So this is from a few years ago, but if you look, no, this is this is now actually. But so this is these are 10 gig links, and we have less than 100 megabits. So. Well, sometimes it goes up a bit. Let me check. Yeah, you see the maximum is like 500 megabits on all transit links combined. So we have some some margin to have more traffic if you want.
Yeah, I expected something like that. We also don't see so much traffic on our links.
Yeah, but that's on average. But once you start getting people connected with fiber, I mean, you can have spike that can go quite high, but you won't see them on the graph. Yeah.
Local content services, Jitsi.
So the way no, it's a good question. So first, we give a public IP address to all subscribers, which is one thing, and we encourage people to host services if they want. I mean, they have IPv6 and public IPv4, so. And even if people want to have several IPv4 addresses, we can give them to them. Because some people want to separate several services or whatever. So this is the first thing. And like, so I don't live there anymore, but I was hosting a lot of services on my own connection to this network, and other people do it. But then we decided that we only wanted to do networking in this structure, but in the same infrastructure, there are other non-profits that are doing a lot of services, and physically it's in the same data center, the same location. And so there's one in Grenoble which provides email, mailing list, Matrix, Nextcloud, not Jitsi, but they maybe will soon be a BBB, big blue button. Let me check what they have.
Oh, BBBs, yeah.
Yeah, Etherpad, PeerTube. We have a lot of PeerTube. GitLab. Yeah. And so, but basically, this is a different non-profit structure. But since it's in the same network, you can still say it's a local content. Because when you are connected to the wireless network, you are really close to these services. But it's also accessible from the internet. I mean.
Can you showed just briefly that Raspberry Pi, the cube thing. Is this part of FDN in general, or is it a subset?
It's not actually Raspberry Pi, it's Olimex. It's open hardware from, I don't know which country in Eastern Europe. But it's not so much active now. So this was a national project. You remember the map I showed you before? So we have a federation that tries to organize a bit things to help people share what they do between each other. And this was one of the projects that was, let's say, a national project. And the idea is that you can have this small device that you can put in your home. It will use a VPN to connect you to one of the non-profit ISP here, okay? Because in some places you cannot deploy your own network. So let's say people just take a FTTH connection from Orange, from France Telecom, and they put this to create a VPN to their local non-profit ISP, and then it creates an access point that uses this VPN. So you connect to the access point and you are on the non-profit ISP network. It's a bit virtual because it goes through VPN, but that's the idea. And you can also host services on it. Okay. And there's a project which is called YunoHost, which is still very much active. It's basically distribution. It's based on Debian, but you have a nice web interface, you have apps, and you can just click and install Nextcloud, click and install a webmail, and everything. So you can use it on a virtual machine or whatever. But the idea of this project was to combine YunoHost with this hardware, so that the goal is to make it very easy to host your own services at home, and to be on a non-profit network at the same time, let's say. The choice is very clear, but and yeah, this is quite a nice project. Nice.
Why did it slow down? You said it's sort of...
Again, support, user support. Because it was not so reliable, the SD card tend to break and so on. So actually, it's been a few years since I stopped following what they are doing. But I think, because yeah, part of the idea was that each local ISP would help people to set up this. And maybe you would buy 10 devices so that you could sell them to people that want it. But this was taking, at least in my ISP, it was taking too much time, so we stopped. But I think people can still do it themselves if they want.
So the lead of APC, he just told me that YunoHost made massive developments over the past like 6 or 12 months. Like they cleaned up the user interface. It's stupidly simple to install and use, and run and host your own services. So maybe it's time to revisit it and see if it's easier to onboard new people.
Yeah, but I mean the difficult part was really the hardware, because it was not that reliable. And so, I mean, the idea is to make it easy, so you give that to people that don't know a lot about computer science and this kind of thing. So when it breaks, they are not really autonomous.
Yeah.
And so, on the software side, YunoHost is really great. I mean, maybe I can show a demo.
Just wondering, should we do lunch? It's at 1 p.m. until 3.
Okay, expired certificates. Let's say it's not a big problem. And the nice thing is that there's SSO, single sign-on. So basically, you log in once, and all your applications, you are already logged in. You have one account for everything, which is very easy. So here you have all your applications that you have installed. So let's say I want to use RunCubes, that's a webmail.
I like the asshole that updated the tag down in the top left.
And here I'm already connected with my account. So, okay.
And federation between the installations. So if you've got these boxes all over the country.
I don't think there's any federation. No. There was a project to do backups between instances, so that you can host backups from other people and you can back up your own instance to other hosts. But I'm not sure if there is more federation than this. And then you can probably create new accounts. No, okay, I think you have to be an admin. But if you are an admin, you can create new accounts for people. So really, you have a single web portal where you can do everything and have all your applications. Yeah.
Just maybe briefly, now that talking about the usage and services, is also abuse management a considerable amount of work for you? Do you have to work with law enforcement, something like this? Do you get regular emails, please disconnect this IP, or what is the address of this IP?
Oh, so when you're an ISP, you get a lot of emails about peer-to-peer usage.
Okay.
But mostly it's crap. I mean,
okay.
I mean, we get emails from India, from the US, and it doesn't apply to France, so we don't care.
Okay.
Yeah. It tells you, oh, this IP address is doing a BitTorrent and it downloads this thing. And you're like, okay, cool. That's
okay.
Doesn't apply to us.
Okay. It's not, the law, and I'm not don't know how the law is in France about this or this. Is it more strict or?
Actually, it is supposed to be forbidden, and there is something called Adopi, which
doesn't exist.
Not completely clear, but
it's merged into.
Yeah, it's merged with another thing, but yeah. It started maybe 8-10 years ago. People starting chasing people that do peer-to-peer because it's bad to fund creation and so on, which is, let's say, mostly bullshit, but anyway. And they started to have a system where if you get caught downloading, you get a warning. So they sent you a letter saying, oh, this is bad, you shouldn't do it. And if you do it 3 times in a row, you get you have to pay some money. And if you really do it too much, you can get prosecuted and so on. So that's the theory. And in practice, this entity that is trying to control this is working with the big ISPs, but not with the smaller ones. So we don't have any.
Also, in practice, if you get a letter once, then you get a VPN or something.
Yes.
A friend told me that, of course.
Did I understand it correctly that the central router does DHCP for assigning the public IPv4s to the subscriber routers?
Yes.
Okay.
Exactly.
And you have also IPv6 or
yes,
they're parallel?
Okay. Yeah. It's also with DHCP. Yeah.
Ah, okay.
Yeah.
Okay.
DHCP v6 prefix delegation.
Okay. Mm-hmm.
Which works good with OpenWRT.
Yeah. And with multiple IPv4, you just statically assign them when the people have services or so.
It's it's a bit more complicated than this, but we actually.
Or you let the VLAN passing through that they can have.
Oh,
their
no
own...
VLAN.
No,
it's the same layer 2 network.
Same, yeah.
It's just that we route an additional IP address on the first one, the one which is assigned with DHCP.
Ah, okay.
And then this is announced with OSPF to all the network.
Okay. But you have not any system that somebody could use a wrong IP when he's connected to an antenna like 50 other people's. He just if a subscriber is connected to your access point, and on his open WRT device he would set a wrong IP, you have no mean to disrupt the connection, or it makes a problem for you.
It can make a problem, yes.
Yeah. Okay. Yeah. Okay,
actually, it depends. It's if anyway, if it's on the same layer 2 network, because basically let's use this one. Each from each router that we manage, we have a layer 2 network, but this is a different one than here or here. Okay, and if somebody here is trying to take the IP of this one, this will be a problem. But if you try to take the IP address of somebody here, it won't work.
It's not routed.
It's not routed from infrastructure. Yes. Okay. But having a single layer 2 network is sometimes annoying. What we have sometimes is that people take their home router and plug the connection to our network on the wrong port, and so they start doing DHCP for all of the people on the same network. And we haven't. It does not happen that often, but from time to time it can happen. You quickly see it because then everything stops working. So, okay. And try to find who this is, and you disconnect them from the wireless network. Or you tell them, okay, you have to plug it on the right port. Okay. So we haven't found an easy way to prevent this yet.
Merci beaucoup.
You're welcome. Okay. Thanks. Yeah.
Do anyone know where is this being streamed? Like the direction of the streaming? YouTube, like Battlemesh or YouTube, or do we have an account from Battlemesh or on YouTube?
I don't know, but on the website it's in the YouTube.
Okay, thanks. I'm gonna look it up. You do the stream, okay. Nice.
Yes, yes, I am used participating in not participating for sure. Yes, in Mario. I wrote you one. Yes. I put the wrong year. Yes. Wow. I think we will do something. We didn't prepare anything. Lander, you're from Italy, who actually is active in Bologna. Is going to come. I have Christina? Yes, Christina. Yes. Okay, great. I actually didn't prepare anything. But yes, something we will do. It was a 1 hour presentation. Yeah, it was great. I don't know. She should speak because Christina has actually the information say about all technical skills that I remember because I'm reading less and less. If you want, well, I will do it.
Fiber is very.
You are local? Are you from Rome? No, I'm from Bologna. But I'm living in Barcelona.
We actually, I think we are one of the last.
I'm local, more or less, but I'm not local anymore.
About something and like disseminate this information.
How much your participation in Battlemesh? How did you start?
Because Battlemesh was founded by some people from Argentina, some people from Italy, and some people from Fuxjäger. Well, the guy from Italy was a guy I was in the same collective with at the university in Pisa. What's your name? Gio? Yes. So I was in the same collective, so we started building a network in Pisa. We started library. He started the library, and I just followed. I like the project. No, altogether with the other people and some of the and so then he moved here. They came not here, in Barcelona. And I moved to Barcelona after visiting him. Well, actually I moved to Catalonia. I just this year moved to Barcelona. After visiting him, I Barcelona a lot. And then I got involved with it. I actually do mostly and Battlemesh and the community bounding. They really don't do the rotation. People in the process. The Argentinians are really focused on the literary project. It's very friendly, but the communication is not really taking care of. So it's a really friendly forum, so the repositories are basically still partially the same, so it's still the same folder, they still contribute a lot of the Battlemesh, but they were 90% of the energy. So now that they are away, they do the releases of Router OS, but there is no release of Liber, which is illegal. So like, people now wanting to use the Battlemesh, they are starting to use Router OS on devices other than Router. So like,
but if it's popular enough in Frankfurt, then is somebody staying here? So we need
yeah, for sure we will do shifts because I was waiting for the people of the
Alessandro.
Yeah,
It sounds like we would stay here for a while.
I don't know, that's like
waiting for you to return. Okay, so we will.
If we go away, it's because they are back. Please, if I go away, it's because they are back, and they will watch over the kids.
Alessandro has some recommendations.
Yes. Yes, that's what it is. Yes, that's what it does.
On the wiki, there are some. Try to put something on the wiki. There's a link. We just click on one thing to the.
Well, late summer, early autumn. That's probably the most important thing right now. When we do next, quiet in the city.
Food!
Hasn't started yet.
I have food. I was hungry, not hungry, more than hungry. Angry, whatever it is.
Both.
Angry and hungry.
And so you didn't have lunch and you brought something for the afternoon as well?
No, no.
I can bring that one out if you know. And for some food.
And how do I switch to live?
Are you telling me? I would stand here and I would switch to slides.
So, work it. 1, 2, 1, 2, 1, 2. Check. 1, 2, 1, 2. Check. Are we streaming? Are we live? Okay. Hello and welcome to Battlemesh v14. And I am here with the Orga team to make a short presentation about Battlemesh, where we are, and what we will see. So, what is Battlemesh? If it's your first time here, this is an event that aims at bringing together people from across the globe to test the performance of different routing protocols. So it starts. It has a very, let's say, technical aim, but it also is an event with a social character. So I think this year we will focus more on the social part and on talks and less on the testbed, as this year's event is a bit shorter than usual. So we already had plenty of battle meshes from Paris, Brussels, Bracciano here in Italy, San Bartolomeo del Grau in Catalonia, Athens, Aalborg in Denmark, Leipzig in Germany, Maribor, Slovenia, Porto, Portugal, Vienna, Austria, Berlin, and Saint-Denis in France. And then in 2020, we had the virtual global edition. That is, it was only online due to COVID, of course. And now we're trying to resume the live event in person. So why are we here? So there is another event going on this week, which is called Rome Hack. And they contacted us and said, why don't we do a joint event all together, like a battle mesh inside the camping and whatever. but we understood that the two events were not compatible, as the Roma camp is closed and has tickets, and it's completely another type of event. So we decided to see if we could do an event in Rome and then go to Roma, who wants to go. And we also thought that Rome was easy because it's well connected. It's a city. You have flights coming here. You have public transportation and everything. And also we have a free location, which is this one, Fuxjäger. And so in times of uncertainty with the pandemic, which was a bit coming and going, and we didn't know really what was going to happen in September, we decided for Rome. So what is Fuxjäger? So this place has been Linux headquarters since the early 2000s. Well, not really this place, which is quite new. It's less than 6 months old, so it's quite new. But the association Fuxjäger in the other building is there since a long time. It was also in another part of the city, and we were also there when that happened. And they also came to Battlemesh v3 in Bracciano. The Fuxjäger guys were the ones that were singing and playing instruments near the lake, if you remember that times. Okay, please. Okay, so Fuxjäger here is in the Alessandrino neighborhood, which is considered a bit the outskirts of the city. And the association tries to bring some sports, education, culture, and all the rest, music, art, whatever. Please. And we will have some streaming for this event, thanks. Also, some equipment was brought here from Vienna. And
the link is on the wiki.
The link is on the wiki. And after this event, some of us will go to this Roma camp, and we will have some workshops there. The idea is to teach how to build mesh networks with WWRT and stuff like that. But Albert knows more. I think the presentation is over, and let's talk. Wanna say something?
Yeah, real quick. This is the wiki page of Battlemesh v14, and this is, as we hope, everything that you need to know. We will do announcement on this page as time progresses. So much of what's going on here you already know. You found the location, obviously. There's more information about the other rooms as well. The timetable is important. We are somewhat on time, I think, and there will be talks following this opening ceremony as well. Tonight in the evening there's this welcome pizza event. I hope you registered on this framer date and told us that you will come. Directions for the pizza event I think are on the wiki already. And if not, then most important thing to know is that the pizza place is relatively close to the hotel, right?
Yes, the pizza place is close to the Malatesta metro station, so you can walk from the hotel to the place. And also I would like to say that that event is sponsored by the Freikorpsverbund Association, which has a name in German which I don't know how to pronounce.
And I forgot it. It's written right here. Förderverein Freie Netzwerke e.V. So this is the official name, and these guys are sponsoring us, which is very nice of them. For Tuesday, there's quite a lot on the schedule already. Don't forget that we also have a little bit of time reserved for lightning talks. Hope you can see this on the screen. If not, as I said, it's all on the wiki. So you can organize yourselves and maybe propose something that you want to present from your current work or whatever it is. Same goes also for Wednesday. And on Wednesday evening, we also have a social event, which is in the Pineto walking area. Maybe a few words?
Yes, so the idea is to go to the Pineto walking area, which is close to the hotel as well. And yeah, there are plenty of places to eat and drink. I think we will try to aggregate everybody in the same place, but it's something in the working.
And on Thursday, the event is already over, so we close at about noon with 2 more talks and a closing ceremony. And afterwards, as Klaus already said, some of us are going to ROMhack. Paul, do you want to say something as well? I think you should.
What? No, just continue. Continue what? Discussing the schedule. No, you said I just have to do this. Yeah, I would say thanks to this guy here and this guy here. And who else? Who is
you?
No, it's just we were just sitting in some Jitsi meetings, so that's all we kind of did. Yeah, thanks for showing up, and let's have a great time here. And yeah, whatever happens.
Sponsorship.
Sponsorship. Yeah.
Sponsorship.
Okay, what did
the sponsors who offered money for people to? Oh, sorry. These are sponsors that gave us a bit of money for people to come here who couldn't afford to travel. And also the venue, obviously, we're not paying for that, and we are very grateful for that. Exo.cat was our host for all of the meeting infrastructure that we used in the preparation. And Freifunk was already mentioned for sponsoring our pizza event. Thanks, everybody. That's very nice. The information about getting around, taking the metro and buying tickets for that, I suppose no one of you has missed that, and you will find your way throughout anyway. Anything else that we need to talk about?
Yes, perhaps about lunches. So we have not organized any lunch, so you can go on the shopping mall or in the neighborhood and grab anything. And also, if you want something to drink, coffee or whatever, we have a kind of cafeteria on the other side of this roof. So if you want to have something, just ask somebody from the local team. That is me, Alessandro over there, Hispanico, Marco here. And yeah, I think I don't see anybody else from from the local. Not yet. Yeah, they will come. Okay. I think that's all.
Yeah, just one important bit of information. Lunch on the timetable is clickable, and this has a few options that you can read about yourself. Yeah, I think.
Everybody can add more.
Yes, it's a wiki, so you can add more. If there is something that you particularly like, then please feel free to add it.
Something came to my mind. For lightning talks, I think the idea of a text file who will be handling the schedule is to have a flipboard here so that everybody can just write on the flipboard if they want to do some lightning talk.
And with this, I suppose Battlemesh is officially opened. Enjoy yourselves and
relaunch successful.
I think we segue right into the first presentation. Can we do that? 3 minutes? Okay. So we segue into the next. We segue into the next presentation. It will start. I don't know what time it is. At 4 sharp, I suppose. Thanks a lot.
Moritz.
Yeah, but what?
He still has 2 minutes.
180 seconds. Something.
Yeah.
Sind sowieso beide nacheinander.
Ja.
Anyway, I think I will hold one, and that's enough as one for today.
And do you want to do it with that ice cream cone type of mic, or with the one that you can clip on? Which is
I
not
don't
live?
really care.
Okay, you go. Are you okay?
Hello, ice cone.
Are you okay with being streamed and recorded?
Yeah, I guess that's okay. But first I need to somehow connect my laptop. Oh, there's a cable. What could it do? Okay, it's disconnected. Oh, it's HDMI, so yeah, I can do something with that. Okay. Now the most boring part, figuring out.
And according to the tool, it's mesh routing for beginners.
Oh, no, I will hold the other one. Because I haven't looked at the slides yet since some time, so...
According to the schedule.
Okay. Let's see if... Oh yeah, there's something. But it's weird. One moment. Okay. Let's see. Is it better? Yeah, might be. Okay, now one moment. Okay, let's see, full screen, and then we can start. Yeah, okay. Yeah, looks good. Okay, we can start. That was less promise than that I would have expected. Okay, so since everybody can read, the topic of this talk will be about old and new ad hoc mesh protocols. And since actually there is not that much new to talk about, I will just go back into the past, go to the present, and then, well, what everything is new. So let's start right out with basics. Mesh networks, what do they do? Well, I guess we all know what mesh networks are. It's just computers or nodes, would be a more abstract term, that are connected, that see certain neighbors. And the thing is, there's no real restriction in the way these nodes are connected. And the most dangerous thing, when you ask a networker maybe, is when you have loops. So if you have a packet and, well, these nodes route a packet, they give it to next neighbor or many neighbors, and those neighbors will also then forward these packages. And if they go in a loop, you can imagine that will be pretty bad. So at some point, I guess the packet will just drop out of during the high acceleration. Well, not really, but it will kill your network because maybe packets get duplicated and will accumulate and eat up all the bandwidth, and then your network is basically dead. So what mesh routing protocols usually do, or algorithms, is in the first place prevent loops. Also, mobile, it just means that the topology changes. Let's imagine like a Wi-Fi router on top of a monkey. The monkey is going around, so the router might see other routers and then other routers and yeah, stuff like that. And ad hoc, I mean, this is all about mobile ad hoc mesh routing protocols. Yeah, there's no existing infrastructure. You can set up nodes at any time, anywhere. Okay, so since we have settled that, let's go to routing software, because that is what this talk will be about. This is basically begins with algorithms, then protocols, and then actual implementations that come, and these three things come from different areas. For example, research, they mostly care about algorithms, and then they do some specific implementation, and for that they need an actual protocol with headers and offsets maybe. And yeah, and that's usually where it stops, at least after the paper is published. And what you can use then is maybe not that good.
I mean, I guess that was in the beginning with OLSR the case. It's of course not a problem anymore, but that's how most stuff started out from research. With commercial stuff, yeah, there's a lot of planning. So algorithms are usually around for a long time, and then people need to solve a problem with an algorithm, so they make a protocol out of it, make an implementation. But, well, often it's not what we need as a community, maybe. It's also maybe closed source. There's, of course, exceptions. We will maybe come to that. And, of course, mesh routing communities, which then often have to develop their own protocols and implementations on top of that to get stuff done. Because what is in research is not of what they need, and from the commercial area, all has also its drawbacks. For example, it's not open. You don't really know what it's doing, or you need to pay money. That's just not possible. Okay, let's start out with some examples way back in the past. Maybe one of you persons have heard about destination sequence distance vector routing. That's quite a mouthful. I think there's this thing that is interesting. It is proactive. That means that every node in some specific interval announces itself and floods the entire network with some "hello, I'm here" message. And if I know from somebody that this node exists and I get this message forwarded by some neighbor, then I know, okay, through that neighbor I can reach that node who sends this hello message. This is basically a distributed version of Bellman-Ford for those who have heard about this. The distributed version is rather simple to understand. The Bellman-Ford algorithm back in university wasn't that simple to understand, at least to me at the time. Anyway, I think this protocol is more like of an academic origin, and also I don't know if there are any actual implementations that you can use and that work. As I said, with academia, mostly after the paper is finished, the software is, well, on a shelf somewhere and collects dust. And for packets, yeah, in the packets, on a node you have like a table that is basically what distance vector is, yeah, more or less about, with a number of hops like in the direction, the next hop, and use these sequence numbers just to make sure that you prevent forwarding packets that you already have forwarded. Okay, let's go quick forward. This is ad hoc on-demand distance vector routing. That is maybe an example for reactive protocols. Reactive is basically nobody does anything unless there's actually something that needs to be routed somewhere. Otherwise, it's all quiet on the front, but when you send a packet to somewhere, then the node will try to figure out where this destination is. And actually, this is something that is used in ZigBee and maybe other applications in your house. Yeah. Also, a lot of this protocol is also used quite extensive in academia. You have this as a comparison or maybe some person wants to improve something, some aspect, and then they make a paper about it. Anyway, you have this routing protocol mentioned in a lot of papers, and also there are a lot of implementations of varying quality and applicability. I have some names for implementations in that list, and what is interesting here is that these three-letter or these letter acronyms there are usually some university. UU means it stands for University of, I think, Uppsala, and UCSB stands for University of California, Santa Barbara. Thank you very much. I was struggling there. Okay, so let's do another stop with something that you might be already familiar, OLSR. It's a good example of a so-called open link state routing protocol. What it means basically is that every node knows the entire topology. While the protocols I presented before that, and maybe even after OLSR, are mostly of a different kind, so-called distance vector protocols, where every node knows the direction where a node is. So when I want to send a packet, then I know, okay, it's in that direction. I need to just forward the packet to this neighbor. But after that, I don't really know how this packet will be forwarded further and further. That's for those packets, for those nodes after that to solve. Both have, for different applications, pros and cons. I don't really want to go into that maybe. I think most protocols, mobile ad hoc mesh routing protocols are, are distance vector type of kind protocols. Okay. Anyway, for those who are interested, just a few key points here about OLSR. I've checked the Git repository there, and you see it's active, not really anymore. Mostly active between 2004 and 2019, and after that I don't think I saw any or many new commits. Maybe now a few more. And I also did a quick shortlist of the committers there, and you can see that Ferry and Henning are mostly the main drivers here in terms of commits. You might know a few other names there. And and after OLSR, there was a new development by Henning Rogge. He made it into a framework because OLSR was quite static and this didn't really have a plugin infrastructure. So I think there was this effort to make it not only IPv6 compatible to support it, but also to have more plugins to clean up the code. But as far as I could see, there was also not much development after 2018. Okay, now let's get to Batman-D. I've been told the story goes this. In the beginning, people, I think in Berlin, tried OLSR, or at least from Berlin, tried OLSR from a research project, and it was very bad. Then, and basically, because of that, they thought, okay, we can do it better, or we need something that is really working in practice. And that's where Batman-D came in. Back then it was, or it is a layer 3 distance vector protocol. So not layer 2 with Batman Advanced. I will come to that. Also, maybe for those who are interested, Batman-D was mostly, well, I see mostly commits from Marek and Sven there. Maybe Marek will turn up at some point. And there's a website for that. Nothing really interesting. I mean, of course, if you're interested, just read the wiki. And of course, Batman Advanced is something that may be more familiar with most of you people. Yes, it stands for something, a better approach to mobile ad hoc networking. And the interesting thing is that nowadays it's part of the Linux kernel. So it's a Linux kernel, it's very fast. Maybe it had to go into the kernel because it wanted to go to have a better bandwidth, maybe to go to layer 2, and maybe that's easier in the kernel to do than in the user space. Anyway, it was quite successful in the way that it's now used by 95% of Freifunk communities, and I think it's also oh, there's still some German in there. Never mind. In use in lots of commercial projects. I don't really know the details there, but it's lots of features and it's still developed. It recently, a few years ago, switched to a new metric, bandwidth metric. Before that, it was packet loss metric. You can still switch between both. I think the code is still there. And yeah, Batman Advanced basically creates a big, huge Ethernet switch. And it works surprisingly good, even if you have like hundreds of nodes. Okay, and you can see I already did the same thing and checked the source code repository, and also I see Sven, Marek, Simon, Antonio, Linus is somewhere here, contributing a lot, and some people here still work now work in a company together and maintain Batman, and that's very nice. So it's an active development. Of course, there's a website. And now a quick detour. In the beginning, I think of Batman Advanced. Oh, sorry, Batman D. There was Axel Neumann, who was also involved there, I think, and he came more from academia, I've been told, and he wanted to have more switches. So yeah, there was maybe some different view, and so he did forked BMX6. Yeah, with to have just more, well, in the first place, more and more switches to try out different stuff. Yeah, I don't want to go into all the details here. What I can say about BMX6 is that's surprisingly good. I tested it and compared it to Babel, to Batman Advanced, and actually was really good. I was surprised by that, but I don't really know how it works.
Sorry, what do you mean by switch?
Lots of switches, command line switches. So if you want to write a paper, for example, you want to try different scenarios, different parameters, and in a routing protocol you have a lot. You have timing parameters, stuff like that. And yeah, and of course, if you have that there, and then you give it to a normal user, well, kind of like people here, then, well, I tried that and I was quite confused by, it was a lot of parameters and didn't know, okay, what does this switch do? For that you really have to understand the protocol, and usually it's not something end user should bother about. But if you want to write a paper and try out different stuff, explore, then that's maybe the way to go. Okay, then BMX7, basically further research with RSR signed node description, so packets that are signed. So you can say, yeah, these nodes I trust, those I don't maybe, and yeah. And then I can route a packet and it will be only routed by trusted nodes. Maybe not something that is useful in a community mesh network, but still maybe an interesting thing to look at. Yeah. Also, the BMX6 website is not functional anymore, not reachable anymore. I don't know why. Probably not enough interest. But still, I can say that it was surprisingly good when compared to other routing protocols. Okay, then now let's go to Babel. It's work from Julius from Paris. He's a professor there. And yeah, basically it's a proactive distance vector protocol, yeah, inspired by others. I already mentioned. It's a layer 3 daemon, and it supports IPv4 and IPv6. Yeah, maybe I have some details to the algorithm, maybe not, I don't know. Yeah, development started 2007, and also it's used in commercial projects, I've been told. Yeah, maybe let's, oh, no. Well, if you care about the details, then I can recommend those two videos from the Battlemesh, previous Battlemeshes. Maybe just look up on Google the titles, and there Julius and other people will describe how Babel works. It's interesting, but I have to say I don't have a slide for that. Yeah. And now for something new I discovered. I've told you at the beginning there are not that many new routing protocols. I discovered basically just one. I mean, there were others, of course, but they are already dead. So this one is a bit more interesting since it's alive and kicking quite well, and it's very promising. It's an experiment from people from the Matrix element community. I think that's an app you can use for chat. Many people here have it maybe on their phones. And yeah, they also have this problem with mesh networks. Maybe not as we have, like with ad hoc and Wi-Fi, but it's a similar space, or at least an overlap. And it basically works with a spanning tree and a DHT that runs over that. So you could say, wait, spanning tree, that's like OSPF, it's not good for mesh routing. And you might be I might be tempted to say yes, but the thing is, of course, you can always, like, even if you have a spanning tree protocol, use shortcuts on something, and still get to a point where it's really, well, not really distinguishable from usual mesh routing protocols. Yeah. Okay, I have more slides for that. The thing is, okay, first it's implemented in Go, and this is more like a research project of these two guys. What they want to do is basically they want to develop a new mesh routing algorithm that they can use for the Matrix protocol, I think. And so they decided first to create a mesh network, mostly an overlay network over the internet, to figure out stuff, and they're actively developing the protocol, and the algorithm changes, and soon it will change again. Not that drastically, they're mostly fine-tuning stuff, and so far it looks very good. And yeah, here's one picture of the network. So basically you have nodes. They create a public private key pair, and then they announce that, say, I might be the root node, and then every node will do that the same. And if they get a packet from a node with a higher or lower, key, packet with a key that is lower or higher, depends on the version. They change it a lot. Then this node will shut up and instead announce this one. So in the end, one node in the network will then send out every fixed interval some packet. Everybody will receive it and forward it, and from that the whole structure of the network will be constructed, and it will be used for routing. But it's not only the only structure that will be used for routing. If a packet is routed through the net, and a node has something like a shortcut from one part of the tree to another part of the tree, then this shortcut will be taken. Currently, this network has about 6,000 nodes, at least 6,100 as of yesterday. Like a few months, it was like 5,000, so it's grown quite quickly. And the interesting thing is that it's since it's a spanning tree protocol, it scales very good. It has a potential to scale with log n instead of n, which would be, for example, Batman and Babel and stuff. So that's quite interesting. And I also tested I tested it with OpenWRT with some 802.11s. Usually you disable then forwarding, and then you start Batman, and then it will use this MAC plane to do the mesh routing. And you can also do the same stuff with Yggdrasil. And I have to say, yeah, it was possible to route over multiple nodes. So that was quite promising, even if this protocol, this daemon, this implementation only mostly works as an overlay network on the internet. Yeah, okay, this is how it works in different versions. Maybe I don't want to go too much into it. You can read it. I have also some links, I think, how it works. In one of the earlier versions, okay, spanning tree with a DHT core implementation, some crypto root. The root node is the one with the highest key, and then it changed with 0.4. There, the DHT is not a circle anymore, if you know how a DHT works. Now it's a line because it doesn't really have to be a circle. It doesn't make that much sense for this use case. So they called it snake because it looks a bit like a snake. And basically you route something on the via the DHT, but if that on the tree, and if you have a better path with the DHT, then you take this one. Basically, yeah, it's a spanning tree with shortcuts and a DHT inside. So that's quite interesting, and it apparently is as good as an mesh routing protocols like Batman on the algorithmic level. In practice, I haven't really compared them a lot, so I can't really tell much. But the algorithm is quite promising, and maybe we can apply something for mesh routing communities to get big fat networks. I mean, huge networks with not less than 1,000, but maybe many thousands of nodes, without killing the network with overhead. Okay, so there's a website, also some nice videos from the FOSDEM, how it works, so you can also look that up. And basically, yeah, that's the end, and maybe the start for new routing protocols. I hope there will be more in the future, because in theory we can do a lot better than we currently do. And as maybe most people experienced with, for example, Freifunk, these mesh routing protocols at maybe going through to 1,000 nodes, the overhead is quite big, and usually what communities did in the last 10 years was like creating central nodes and then connecting, using that as gateways between distinct mesh networks that are not allowed to mesh, because otherwise the mesh network domain would be too big and everything would burn and explode. But having like a central server is of course not nice. So yeah, let's hope for the future. Maybe there will be better routing protocols. It's possible, I believe that, and I think everything that I've read agree. And I haven't seen a lot in that area, anything new. So let's hope that the newest research gets into practice, and we will have big, huge mesh networks. Thank you very much. Oh, any questions? If not, then I would say, yeah, feel free to approach me afterwards. Yeah, and have a nice day.
Maurice, I think that you are the next presenter as well, according to the schedule.
I don't feel like to do another talk right now.
Perfect. So should we have a break? If there are no volunteers to get their stuff, I don't know.
Oh, actually, I came out for about half an hour, so that was according to schedule. Yeah, I'm surprised. I was thinking it would be much more. Oh yeah, a question. Sorry, I will come around.
I'm just curious, like, is there a mapping of which networks use which protocols?
Okay, your question is if there's a mapping, what networks, community networks use what protocol. Well, I think there's a public list or something. I know that most community mesh networks in Germany, like 95%, use Batman Advanced in different kinds of versions. Maybe some are still using an older Batman version that uses packet loss metric. Then there are a few communities in Germany, like Berlin, I know of, that use OLSR. I don't know about the other mesh routing communities. Yeah, Freifunk.net, yes, there's a list of all the communities and what routing protocols they use, but yeah, we can just summarize it with, yeah, most of them use Batman Advanced in some form, and some use OLSR, and then there's maybe 2 or 1 that experiment with Babel. Yeah. Giphy in Spain, actually they don't really use mesh routing. What they do is mostly point-to-point links, maybe with BGP, and I think they have some experiments with mesh routing, local mesh routing clouds, but that's it. And with in New York City, what's the name?
NYC Mesh.
NCY Mesh. NYC Mesh. Okay, I think people will get it. Okay, they use OLSR, you say? OSPF. Okay, so not really mobile ad hoc mesh routing protocol, but a spanning tree protocol that is usually used in most data centers.
I think there was also a BMX6 mesh network in Catalonia.
In Catalonia, BMX6, yes. But is it Giphy?
Yes.
Okay. I just said that Giphy doesn't really use mesh networking, really.
It's a small island. Small island in Barcelona.
It's a small island. Yeah, one guy from there told me once that they don't really do mesh networking. It's mostly BGP, and they have a few experiments for small islands. Yes. Okay, so you say also BMX6 is used there. Okay. Yeah. Okay. Another question, Hauke.
Do you have any protection against bad ASICs, so bad mesh nodes that want to point traffic to me or want to the network somehow?
So your question is if there are some mesh routing protocols that can defend themselves against bad neighbors that say get me all the traffic and then I will throw it away. Yes, there's a lot of yeah, BMX7. Yeah, that's aside. There are a lot of papers that deal with that, but for actual implementation, usually I don't think so. There's lots in practice. At least when you really say you want to have something like mobile ad hoc mesh routing. Yeah, I think usually you see something that maybe with policy routing, I would say. It's a similar topic. Well, the thing I can say is, yes, there are a lot of papers describing different approaches there, but for real-life implementations that you can use, I'm not aware of any. Yes?
Is there any advance in the cases of hidden nodes?
Any advances in the case of hidden nodes? I don't know. I know about a few interesting ideas, but I don't know if they're relevant to mesh routing.
Ideas about software solution or hardware solution?
Software solution.
In which of the cases that you present today?
It's none in any of these protocols that I've mentioned here. Yeah. Any more questions?
What is a hidden node?
What is a hidden node? Well, a hidden node is a node that is hidden, of course. So.
Excuse me?
Okay, apparently I was eating. And now they're fed up. Okay.
No. For question, because in the streaming there is no.
I see. Okay. Okay, so you have, for example, on a hill, one node, and then on both sides in the valley, in one node, and then in one valley, the node decides, okay, let's speak to the node on the top of the hill, but the other node in the other valley doesn't know, and also tries to talk to this node on top of the hill, and this node on top of the hill will go crazy and say, hey, you're both trying to talk to me. I'm freaking out. I can't understand any one of you because everyone else is trashing the signal. So that's the hidden node problem.
That's not a routing problem, that's an Wi-Fi problem.
One moment. That is something I have to think about. I would say it's it's an algorithmic problem, but maybe you can, well, it's inherent in Wi-Fi. I mean, you have one medium and you send signals, but nodes don't know when they are allowed to talk.
Okay.
But I think you can solve it with software. I mean, that's what routing protocols are for.
Okay.
Or maybe you can do it on a lower level.
In the best of the cases, are 2 hidden nodes, no? Maybe more.
Oh, I don't know.
Where I live, there is more than one than.
I mean, usually with Wi-Fi, I mean, you have really like on the low level these protocols that well, basically there are two lines of thought how to solve it, where you make sure that somebody else doesn't talk into another person. So maybe if you know that your signal was trashed by someone other, then you say, okay, I back off for a random amount of time and then try again. Yeah, I don't really know the details there. It was a long time ago, so I don't want to go into that without talking too much rubbish. Okay. Thank you very much.
Thank you. We have a talk from Baptiste, who will fill in the missing slot.
I'm sorry?
Baptiste.
Give a talk to fill your slot.
That's very nice of you.
Also improvised. I mean, I already did an improvised talk before.
Yeah, now I need to get this thing off.
Get rid of it.
There.
Can I take the...
Sure, please. Okay, here you go. Don't swallow it. So.
Okay, so as you see, it's completely improvised. I took some slides from another presentation. So I will talk about eBPF. How many of you have already heard about this this word eBPF? Yeah, kind of. Okay, good. So it's an introduction, so that's nice. So basically, it's a way to program the Linux kernel without actually writing kernel code, if you want a large overview. So it's something between user space and kernel space. I will detail the motivation, how you can use it to gain more visibility into the kernel. I will go quickly, but this is the more interesting part, I think, for Battlemesh and this kind of community. So the motivation for eBPF is that both hardware and software is very complex now. You have very many layers of programs that interact and so on. And it can be hard to understand what is happening. And it's also hard to program. If you want to do packet processing at a very high rate and so on, it's not that easy to do. And so eBPF is a way to solve all these problems. And as I said, I will mostly focus on programmability. So if you do system and network programming, for instance, let's say you want to encapsulate packets, to do a tunnel or something like this. If you want to do this kind of thing in user space, it's easy to do, at least easier than writing kernel code. But often you have low performance. That's why, I mean, if I take VPN and tunnels, many people were using OpenVPN before, and now WireGuard is here, and it's much more performant. because it's runs inside the kernel. Okay. So it's one way to look at where you should write your network processing code, let's say. But writing in the kernel is really complicated. Even WireGuard, I think it took maybe 3-4 years before it got upstream into the kernel. If you make a mistake, then the kernel crashes, so that's not very good. So you have to be very careful about how you program. And of course, the interface between these two systems is very strict, rigid, let's say. You have system calls that allows you to, from user code to call kernel code, but it's quite fixed. And the idea of a BPF is to make this much more flexible. So far, did I lose anybody? Is it kind of clear? Yeah? Well, there's not much details yet. Okay, so all the figures they are from the official website, so I didn't draw anything, just took them to illustrate. So the idea is that with UPF you can write code that will be executed inside the kernel, but it's as easy to develop as writing user space code. Okay. So you can write code in, so mostly in C, but you also have bindings in several languages. And then there's a system to load your code into the kernel, where it will be verified to make sure that you will not crash the kernel, let's say. And then it will execute. And for instance, you can attach a program to a network interface, and each time a packet is received on this interface, your program will be called. And you can modify the packet, you can drop it, you can redirect it, you can do whatever you want with your packet. But this is just one example. You can use eBPF in other parts of the kernel. For instance, you could attach a program on system calls. So you could say, okay, I want to know each time somebody is writing a file to the file system, and you can tell the kernel, call my program each time there is a write or a file is open or something like this. So it's a very flexible and it has a large scope, eBPF. But again, I will mostly talk about the network application. Okay, so to try to understand how it works in the kernel, how many of you have used TCP dump? Yeah, more. So you know that you can write this kind of predicate to say, oh, I only want to have packets from or to this host, and if it's UDP and port. So how many of you know how this actually works under the hood? How is it implemented? Cool. I like to explain that. So the first thing you could say is, okay, maybe TCP dump is looking at all packets, and then it filters the packet. But actually, that would be quite inefficient. So what actually happens is that TCP dump tells the kernel to filter the packets. And so the kernel will only send packet that matches this to TCP dump. So that this is really efficient. And the way it works, so inside libpcap, which is used by TCP dump, this is compiled to a bytecode. So it's called BPF Berkeley packet filter. So really, this is meant to filter packets. That's the origin of the name. And this bytecode is very simple. You have a stack. You can you have access to the packet header, and you can say, oh, if this part of the header is equal to this value, then okay, I match, or I don't match. Okay, and so all of this is actually translated to lookup inside the header to decide if you want to match or not. And this bytecode that implements this, it's actually loaded on the socket. So it's not a real socket to do Yeah, it's a raw socket. So it's a way to communicate between TCP/dump and the kernel will interpret this bytecode to apply it on the packets. Does that make sense? So this is, this has been like this for 20 or 30 years, so this is quite old. But it's still an interesting way to program the kernel. Because you are actually loading very simple code, but you are loading code into the kernel that will execute. So it cannot do much. It will just look up headers and so on, but this is still something interesting. And eBPF is basically an extension of this mechanism to do much more things. 30 years ago. Yeah. Okay, so eBPF is the same idea, but with a lot of extensions. So there is some performance improvement, like just-in-time compiling and so on, to make it even more efficient. But the real addition is that you have several places in the kernel where you can load your program. Okay. So here, this was one location. You load it on a socket, and it will filter packets. But now you can, as I said, you can load it on system calls, on internal kernel systems to execute code here. You can access some kernel data structure. And what's also new is that you can communicate between your program in the kernel and user space. So for instance, you could add a kind of simple firewall that runs inside the kernel that you would program from a user space program. But it's very flexible. So these are two examples of hooks where you can run your programs. So this is what I described before, and this is for networking. And there's even support to load your program inside hardware, the network interface. Well, there's one brand of network interface where you can load your programs so that you can filter packets directly on the hardware. And that's even lower than the kernel. So as I said, so it's the same area as the classical BPF. You have your bytecode, which is more complicated, but same idea. You load it in the kernel, it gets verified, just-in-time compiled if you use classical architecture. And then it will stay loaded, and it will be called every time the hook matches, let's say. And this step is actually pretty complicated. I will give examples later. So you can call things like generating random number. You can, you have access to several, because of course you cannot load huge libraries inside your program. It has to stay very simple. And if you want to do more complex stuff, you can call things from the kernel. Okay, so this is very interesting. As I said, you can communicate between your program in the kernel and user space. And to do that, the kernel provides maps, which is basically a key value store. And you define which kind of key you want to store, which kind of value. And then user space can write values and read some values also. And the same for the kernel program you write. Okay. So you can create, I don't know, a routing table, put it here. You can create firewall rules. You can create just configuration. It's arbitrary. I will skip this one. Okay. I did a demo last time, but I can't do it now. Well, actually, I've been adding support for this in a project we developed in our community. So let me see if I can show you the code. Okay, so this is a eBPF program, and it's using. So you remember there were several hooks. Oops. And it's using one of the lowest one in the kernel stack. So the idea is that this program will intercept all network traffic coming on an interface. Okay. And so this project is L2TP server that we use for DSA connection. And basically, we need to encapsulate and decapsulate packets because we receive packets from our provider that encapsulate that in a tunnel, and we need to decapsulate, validate that the packet comes from our subscribers, which subscriber, and then forward them to the internet. So this is quite. It's not that. It's not a complicated processing and so on, but for now we do it in user space. So we have the same problem as OpenVPN, low performance and so on. And so the idea is to do this kind of processing inside the kernel to be able to do it faster. So this eBPF program, it's written in C. So you can include stuff and so on. But of course, since it will be compiled to eBPF and then loaded into the kernel, it's quite restricted. We cannot do what we want. Basically, for instance, we cannot have loops because otherwise the kernel could, I mean, if we go into an infinite loop in the kernel, that's pretty bad. So if we try to put a loop in our program, the kernel will reject the program. It will say, oh no, your program, I'm not sure it will terminate, so I refuse. So that's why I say that the step that verifies your program, it's quite complicated because of this kind of limitations. So here, for instance, so this software L2TPNS, it's managing tunnels, and you have sessions inside tunnels. And to be able to configure the kernel code, there's a map that lists all active tunnels, to which IP address what is the remote end of the tunnel, and so on. And so I define a map that stores this data. And I will be able to access it from my kernel code and to write to it from the user space part. Same for the sessions. There's notion of sessions inside the tunnel. It's PPP session, if you know what this. And now I can write my function that will be executed in the kernel. And so what you receive depends on where you run in the kernel. But for the network part, you receive a context that is basically a packet. Okay. So each time a packet comes on an interface, this code will be called with this is a buffer where we have a packet. Okay. So now it's really low level. So if you want to parse the packet, you have to do it all by yourself. So you have to check if it's Ethernet, then is it IPv4, IPv6, and so on. So I have some helpers that I may show you afterwards, but this is just small C functions also. So we pass the Ethernet header, we say, okay, is it an IPv4 or IPv6 packet? So if it's IPv4, try to find if it's TCP, UDP, and so on. So it's really a low-level parsing. So in your case, it's a tunnel that runs over UDP. So I only want to match packets that look like a valid tunnel. So if it's not UDP, then don't do anything here. And basically, so what's important is that this runs before the normal kernel stack. Okay? Before the normal kernel processing. So basically, if here I decide to drop the packet, nothing in the kernel will see the packet. Even TCP dump, no, it will not see anything. This is really the first, this will run as the first step when a packet is coming in. Yes?
Yeah, what is the difference between eBPF and XDP?
So XDP is one way to use eBPF. Oh yeah, repeat the question. The difference between XDP and eBPF. So eBPF is a general concept, the bytecode format, the infrastructure to verify the programs and so on. And XDP is basically when you load a program at this location, this is XDP. Okay. I think it stands for Express Data Path. Yeah, Express Data Path. That's it. And basically, there is support from the network drivers to call your code as early as possible, before even allocating memory for the packet and so on. So it's really early, because the goal for XDP here is to be very, very high performance. Sorry?
Yeah, I also have very limited knowledge about this, but usually with BPF I'm associating some assembly-like language. And the code you showed, is it something, a library around it, or is it XDP specific, the syntax you could use? Because it looked a lot easier than writing some assembler language to pass stuff.
Yeah, so basically it's a C, but then it doesn't get compiled to machine code, it gets compiled to eBPF bytecode. So this kind of assembly that you're describing.
Okay. And in your C code you don't have to write assembler-like instructions or something like this?
Well, I guess you could, but...
yeah. And where does it come from? Is there some library you can... what was it, BPF, or the... if you show the code? Oh, is it? Ah, like this.
So, the includes or...
yeah, okay, is it like an XDP user space library you can use, which makes it easier to parse the things, or which...
So actually, all this code will run into the kernel. So when I compile it, can I show you? Yeah, I think I can show you how to compile it. It's a bit small, sorry. So let's look at the make files. Oops. I'm opening Vim in Emacs. That's a bad idea.
But it's XDP which provides these nice functions to pass things?
No. You have to write them.
Ah.
You mean this parse Ethernet on something?
Yeah, or like the BPF HTONs and so on, or parse IP header?
Oh yeah, these are the helpers. These are helpers in the kernel.
Ah. Inside the kernel?
Yeah.
Ah, okay.
So it's defined in one of the headers, BPF helpers.
BPF helpers.
Here.
Okay.
Yeah. And so when you compile your code, okay, make. Oh, it doesn't compile because I was changing some stuff. But basically, it takes your C program. So far, only Clang knows how to generate eBPF bytecode. And you just tell it. So normally, target is a target instruction set. So you only use it like if you're on an x86 laptop, you want to compile for ARM, for instance. You could use target ARM, let's say. And here, it's another target, which is BPF. And so it will generate eBPF bytecode. And from your C program, you would get a .o file. So it's an object file. It's not an executable, but this is something you can give to the kernel, and the kernel will analyze it, and if it validates it, it will attach it to this XDP hook. Yeah. And all this BPF something in the object file, it will just be function calls to nothing, because they will be resolved when you load it into the kernel.
Okay.
So it's actually a call to a function in the kernel.
Yeah.
Yeah. And so basically, so for XDP program like this, you have several possibilities of what. So you can modify the packets. Okay, if you just write into the context I was showing as argument, it will modify the packet itself, and then it will be processed by the kernel. Because as I said, this is really the first step. Or you can also so if you return XDP pass, the packet will continue its processing. If you return XDP drop, it will be completely dropped at this point. So that's one of the use of this, is to have anti-DDoS mechanisms, where you say, oh, okay, if I received 1 million packets from this IP address in 1 second, then I will drop it. It's very efficient. And I think you can also say to directly send it back to another interface without going through the normal kernel processing. So you could actually implement your own forwarding mechanism with this, if you wanted. But it's completely independent from the normal forwarding and routing tables. Yeah. So just to conclude. So basically, this is very, very flexible and powerful. Thank you. So it actually solves one problem, which was, as I said, between user space and kernel space. Sometimes you are in the middle, and it's not user space is not performant enough, but it's too difficult to put in the kernel. And also, people at some point try to introduce very complex mechanism into the kernel, and people don't like that. So BPF is a way to add this custom complex thing that you want to do in the kernel, but it's well encapsulated, and with this verifier, you should not be able to crash the kernel in any way. So it's a safe way to do complex and custom processing into the kernel. And basically, many, many mechanisms that go even beyond what I show with syscall and so on, they are moving to eBPF. So this is something that I think in the coming years we will see more and more of this. But so I'm currently adding support for this in our project. It's not that easy because it's very low level, and the compilers, they are not. It's still a bit new. So sometimes you have weird errors and you don't really know what they are. And so for me, it's really worth it for very specific needs. If you need high performance for this specific task, like for us decapsulating packets, it's worth it. Otherwise, I mean, most of people using it are very big companies, and they have 10 or hundreds of people working on it. So you need to have lots of resources to be able to gain experience with all this ecosystem. That's it. Thank you. Any more questions? Yeah.
So it looks like this is the perfect attack vector. If you find a bug, then you can run code in the kernel,
yeah,
right?
Exactly.
So I wonder what you can do about stuff like, I don't know, declaring very large structs with tons of members and eating up memory and do other things. So are there like hard limits that are enforced? And how can you really argue about the runtime behavior of a piece of code when you don't actually run it in the first place to see whether it crashes or produces dangerous results?
It's a very good question. And actually, there are very strict limits. Even at the beginning, you could not use more than a few hundred instructions at the bytecode level. So really, you could not do complex processing because the verifier needs to analyze your code without running it. So this is called static analysis. It's a well-known technique that compilers actually also do. But the complexity can be exponential and so on, so you cannot do it on very large programs. But now they improved the verifier to be able to handle larger and larger programs. Because, for instance, one of the problems, if you have a branch, like if this value is equal to this other value, then do this, otherwise do this. So if you do static analysis, you have to test both paths and try to anticipate what happened in both cases. And then you have other branches, so that's why it can be exponential. But they are improving this, and now you have a limit of 1 million instructions, which is quite a lot. Regarding memory, you cannot actually allocate memory. There's no malloc, for instance. So that's one limit.
Is it stateful? Like, can you process more than packet in one go, or is this really something that's working per packet?
So for XDP, it's really one packet at a time, but you have these maps, and if you want, you can process one packet, write something on the map to remember something, and for the next packet, you can read it back if you want. So often people use it either for configuring from user space to your program, but you can also use it to collect statistics. Like for instance, each time you have a packet, you increase the counter in the map, and then user space can look at it and say, oh, okay, I processed 1,000 packets.
And I guess flow tracking and stuff like this can also... Flow tracking, where you say the connection is just opened, you have an acknowledgement and so on.
You could implement this kind of thing.
And one last question that I have, are there any known attacks or any known problems?
Yeah, there were some. And basically, each time you have a bug in the verifier, it's possible to exploit it. Because, so I don't remember exactly the details, but you can, it's easy to find. Basically, you trick the verifier to think that one branch will always be true, for instance. But because of a bug, actually, at runtime, the branch will be false. And so you can run any code because the verifier said, okay, this is impossible, I don't analyze it. But actually, you can take it and then you can write anywhere in memory. So it's quite bad. I mean, when you have a security issue.
Thanks.
But again, since it's quite restricted in what you want, what you can do, hopefully, at some point, it will be secure.
The hopes are high.
Yeah.
Hi. I often read that the next generation firewall in OpenWRT will be also eBPF based or XCP based. But when I played around with XCP on OpenWRT, I did a small XCP program which was just passing packets, loaded that to a socket, and the throughput drastically decreased. I think I used the MIPSOC, so I think it has no JIT support, but do you think that will be solvable, or is that XCP? So I think it somehow then had a fallback to a generic kernel implementation of this eBPF stuff, but it was really decreased a lot when I did that.
So one thing is that the people doing this, developing a BPF and so on, they are all very big companies that run this on big servers. So it's well optimized for this case. But if you're it on MIPS, for instance, I think you have no just-in-time compiler. So it will be much slower to execute. So?
At least there was some just-in-time compiler
for MIPS.
For some.
I think there was a just-in-time compiler for MIPS, at least for some cases. So I don't know if all MIPS variants were supported.
Okay.
I have to look it up.
Okay. So, but yeah, the fact is that it's not the primary use case of the people developing it, so it's no surprise that it's not so much optimized. And I have no can it be optimized? I don't know. I'm just using eBPF. Yeah, I don't know. But I know, yeah, so Felix in the OpenWRT developer, he added support for eBPF in OpenWRT because I think he uses it for, I don't remember which project, but yeah. Because you need to have this compiling infrastructure, which is not that. Okay, anyway.
Yeah, probably each network provider will need to implement a hook for the eBPF.
Well, this is so you need to implement hook in the kernel for eBPF, but this is already the case.
No, in the driver.
Most drivers do it. So.
Then maybe it's getting faster because
Yeah. But there's another thing is that for now, it's not really portable. Like if you compile your eBPF code on one machine and try to run it on another machine with a different kernel, it may not work so well. So for now, it's a bit difficult to distribute compiled eBPF programs. So for Facebook or Google or whatever, they know which kernel they are running, so it's not a problem. But if you want to distribute your eBPF code to many different users with different kernels, for now it's quite complicated. And it's a bit annoying to have each user having to compile this program. So I think it will take a few years before it's very easy to use eBPF anywhere. Yeah. Yeah, okay.
I just checked in kernel 5.16 is now an eBPF just-in-time compiler for more or less all MIPS architectures except micro MIPS and some weird old things with bugs.
Okay, thank you.
It's backported in OpenWRT, so it should work already with the older kernels in OpenWRT.
Cool.
But with eBPF, I cannot use the classic pcap filter syntax, right? I have to do the parsing all still myself, quite manually in the C code. Okay.
Yeah, it's more flexible, but you have to do more things.
Okay. Would have been nice to if I can have already one line to know. Okay, with this line of pcap filter syntax, I get the packet I want, and I can just write one line in the C code. But
yeah,
no.
that's a good point.
Because I also have a specific use case where people told me that maybe that could be done with eBPF, because I just simply want to count, or I have a list of like 500 pcap filter syntaxes for different kinds of packets, or for instance I want to have more knowledge for Batman Advanced, which kinds of packets are going through, and the only thing I want to get back from the kernel is a count, so how many packets were received for this syntax.
Okay.
And it would be quite cumbersome, I guess, if I have to write 500 different syntaxes. I have to write several lines of C code to get it.
What you mean.
Yeah.
Yeah, that's a good. Maybe libpcap could be used.
Oh.
I don't know.
Okay. Okay.
Maybe you know that. Can I now compile eBPF programs also with GCC? Because but there was some development on it, or?
I think there is some development on this,
but
I
did
haven't
not
followed.
okay.
So maybe it's possible now, but last time I checked, it was not ready yet. Okay, thank you. Another question?
eBPF is already used in OpenWRT, so there's the Felix wrote a QSify system that's able to, so as far as I understood it, it's there to, based on like IP addresses or other things of the packet, it can detect what packet it is and puts it then in the how is it called, these classify it on DSCP rules, and so that then it can be the next QAS system, so like when you put it with your upstream things, your ISP can give your audio things higher priority, or you can put it in the Wi-Fi with higher priority or lower priority, so that your video conference still works and is not disturbed by your game downloads or whatever.
Okay, cool.
Further questions? Last chance? If that's not the case, then thanks a lot for another spontaneous talk. And the schedule says that we have a break.
Ah, ok, perfetto. Quanto tempo ho? Un'ora, 17:30, 18:30. Ok. So.
Se streamiamo, registriamo.
Sì, va bene. L'ho anche comunicato agli altri, alle altre, quindi... Ah, c'è un road. Questo rumore è il vento.
È troppo alto.
Prova. Go. Ok. Good. I'm Andrea. I come from a place near Bologna, a small town. So I can say the name, but probably you don't know where it is. And I would like to speak about the community network that we run in the mountain near Bologna. Some human aspect, some technical aspect. I thought this presentation, this talk, to talk about some human issues that sometimes we have running community mesh network. So it's about practice in communities. I don't know how many people feel comfortable with English. Totally, everyone understands well English. There are people that speak only Italian or Romance languages. No? Ok. Cioè, va bene se parlo inglese? O è comprensibile? Se no, posso fare un po' inglese e un po' italiano? Inglese? Ok. Good. So, okay, what we are doing. I'm a part of a group of farmers, and I'm one of the technicians that runs the mesh network. I studied Italian literature, okay? I'm here self-paying my travel, and in the last 10 years I self-paid my self-voting about the mesh network because I studied Italian literature. And and for work, I am a front-end developer. I write JavaScript stuff. And so I went to live in the countryside in the 2017. And I already know this group of farmers because they are quite famous in Bologna and in Italy because they founded a bigger network of farmers that are agro-ecological farmers. So they grow vegetables only in organic way. So are non-traditional farmers because the new tradition of the 70s is in Italy is a lot of chemical stuff and no? Okay, so it's a new agroecological groups. So we use LibreMesh. We are inside of Linux. We are a community of Linux, and we decided to use LibreMesh as software because LibreMesh gives us the possibility to have to not enter in the shoes of the protocols, but have the experience of other people that do. Also because in the Linux groups that have a lot of experiences because started in 2001, I think. There was a lot of different nerds that use a lot of different protocols and they build their own firmwares for every islands in the Italy, and it was difficult to maintain. And for us, that was a part of a farmer group, it was impossible to maintain. So, okay, this is to share, but probably. Okay, which are mesh network? Mesh network are network where every node is able to route traffic. And so there are not the central points. Why I repeat this here in this meeting? That because the group of the farmers also choose this architecture because there is a political interest in running this kind of network. Okay, so farmers that are of the groups that I'm a part in Bologna, that are, the name is Campi Aperti, they make choose on, for example, on what they buy outside of the supermarkets, and so they make, how to say, consumo critico. They thought before bought something or before deploy and implement something, okay? So mesh network, they put attention on this also because it was decentralized and also take the shape of something that also them was building. Yeah, what take our attention was the possibility of scalability, network segmentation, easy to use about LibreMesh, that we just find the good tool in the good moment for us as community, and the modularity. So also is not one tool for everybody is the same, but also the possibility of change a bit. Yeah, what I was saying, that LibreMesh give you a firmware image based on OpenWRT, OpenWRT, OpenWRT in Italiano, and but the good part that we can customize also for some points, some nodes that are different. There is also this new feature about put more configuration, and the antenna can understand the width configuration used by the MAC address, the point in the MAC address.
And this feature was developed by the local community.
It's true. Yeah. Yeah, okay, some image, some to remember better. And okay, but yeah, we not did this stuff alone. Okay, we arrived in the possibility to build a mesh network because some of us, because the farmers started their activity in a squat, in an occupied place that was in Bologna, XM24. 17 years of activities, was evicted 3 years ago. And also inside of XM24, that squat, there was an hack lab. Hack lab in Italy is an old story for the 90s. And that, so we put the feet on a good, like, okay, we not was born alone, no? The staff born because are on the top of others, and a lot of gratitude for who make the works before me. So, our mesh network, you can find our blog, that is Antennine, that in Italiano, you know that we like Ino, One, Etto, Ella, blah, blah, blah. So it's antenne Ine, small antenne, on noblogs.org, blog that not take logs, and is a service from Autistici, autistici.org, that is a self-managed server from the 2001. So we started the mesh network in the 2017. In reality, just to connect my house. I arrived in the countryside, and the other people say, you're a technician. We are also, go on the roof, please. We bought an antenna, 2 ways, satellitized, and there is a week that we have not the chance to connect. I spend a week, I'm not connected. I phoned to ask a technician. The technician asked 150 euro to connect. I say, okay, I can spend another week on the roof. I have the chance to work with the parabola, but the connectivity with satellite 2 ways have 2 seconds of delay, and it was completely not usable. And so people say, oh, wow, really good, you pointed the antenna, but so maybe you have another idea to resolve the issue. Yes, I was one time in a Linux day. and so we started to build this mesh network. Now, 5 years, we are 15 nodes, 15 nodes on the roofs, and we give connectivity to 50 people over 4 valleys. We are 4 technicians, not 1 for valley. We are not well distributed. So there is the first valley where we started is without technicians, but we are really connected. We have 4 gateways outside to reach the internet, because also the needs of these farmers was connect to the internet. Yeah, the story that I spoke to you, that the first node that was connecting my house with other farmers, that was possible to see in top of a hill, and was a group that make barley for beers, so they know a lot of people. And just in a week arrived people ringing my house, hey, I want a connection like you make for the brewery. Okay. And grow slowly, also because because we want that the people understand. We don't really mount the antenna for them. Like we mount together, but we also give the time to understand. Like if there is not the pole on the roof, okay, we will come again tomorrow or the week after when you will build, because yeah, I mean, if I'm help for technicians, build a pole on the roof is something that farmers can do better than me. Okay, so we have also 4 administrative people that are people that ask the money for pay together the gateway for the internet. And this is incredible that last years in May we found a WISP that changed all the antennas, because it changed from 802.11 N to the AC. And so I have all that antenna and thought, okay, I don't want to go to trash. If I put a person paid to test everything and sell as used is the balance not pay. And so, randomly, so completely randomly, in the same days I wrote in the mailing list, and he gifted us of 96 antennas used. Like it's a dream, no? Oh, I would like a mesh network with used device. No? And we found. And also in the same time, flashing ubiquity and TP-Link was becoming harder and harder, because there was a sign on the firmware, and so flash only TFTP was TFTP was working, but so yeah, in the dream there was also and all device, and come all device. So we use as a software Libremesh, and the 2 routing protocols in the level 2, and BabelD in the level, Bachmann in the level 2, and BabelD in the level 3. Oh no, but this is old. I updated the image just for this talk. And so, yeah, these are the new nodes. This is a UMAP service that we installed inside of the network, because just after 10 devices you start to forget where are and so yeah, well, this was one of the needs. The green are the active, the yellow are the possible. And so there is this valley, this valley, this valley, and this valley. We are also quite lucky because looks like that now are 3 islands, 1, 2, and 3, but looks like that in the time, if we want, we can connect the 3. Wow. That is something of depends from the territory, no? It's not, so we are lucky. But we already is not down, because now we are building the legend, no? To say, oh, one time we will arrive to have the valley united, and so to have a big ceremony or, I don't know, party when we will do.
I wanted to ask, what are the distances?
Okay, yes, this is 7 kilometers, and this is 6. This is the first node. I leave it here. Here there is the brewery. Yeah, thanks for the question.
Are you using OpenWRT on the devices for the 7 kilometer link, or is there something different?
Okay, here we have both are NanoStation M5 Ubiquiti. Okay, this is the other layer that looks like the human network, no? Because the yellow are people that asked to enter in the network, and that is possible to enter. The black is where we tried to connect, but we not have success, but we give them an antenna, so they can try again alone. And the blue are friends that already don't know that we would like that someone say their name. Not someone named, and we put the point, and are people that we think, okay, we have to speak better and explain better.
Puoi ripetere?
Sono le verdi, sono le persone connesse. Le gialle sono le persone che hanno chiesto per Guntana di entrare, e le blu, no, le nere è dove intentamos ma non conseguimos. E che la azul sono le persone che qualcuno ha fatto il loro nome, di dire secondo me è interessato, è interessata, ma non abbiamo ancora preso contatto. No? E sono amici di amici. Ok. Oh, yeah, I put some old photograph. This was the first, the antenna of the 6 NanoStation M5. This is nice because everyone put a different pole, no? Palo si dice, and some are really strange, and yeah, this is in Tuscany because we helped another group. Yeah, I move on.
In this one, there is an antenna pointing to that circle.
Yes, the 6 kilometer, was, yeah, from, it's also the old castle of the valley. So see really well the valley, you know, and yeah, so from this point to there are 6 kilometers. Okay. I have all the other photographs. I chose some photographs for you. Yeah, this is in a window. Wow, this is a Tuscany. You can see that there is a different vegetables. I put it because we helped them to make a link. I'm here in another. I am here there to put another that was just mounting. We spend the place sometimes in social place to speak about the people, ask to put in the map, and share contact. And okay, this is a person that work in, come si dice muratore?
A builder.
A builder of houses. So you can see the style of the pole. Is really no movement. It's really. Yeah, this is another. We have the connection here, but they are only 2 kilometers. Mountain, because sometimes come the people of the house come in the this is nice that she come to make photographs, but yeah, it looks like really scared to me on the roof. But I like it because it's a super nice photograph, I think. So what do we have inside of the network? A lot of fun, yes, and a lot of some services, but more internal services that needs for the technicians. Then I think that there is a lot of potential with the community, but we are still in the moment that the other people need to understand what we can do with the network. So yeah, we just installed the Nextcloud instance. Do you know? I think it's a self-hosted, is a software for cloud, open. We have a transmission torrent now with a VPN also. The UMAP, the software for maps, that was the first needs that we had to not forget where we have antenna. After we put Prometheus and on top Grafana, because yeah, sometimes happen that someone phone, I can't understand. But try to do this, no, let's go to do this, but LibreMesh, what is saying? Okay, I come to you. You go to the arrive and say, oh no, it's in the other side of the valley, the problem. Yeah, because the problem can be in the other points, no? And so with Grafana and Prometheus make a better idea to us. Was a bit problematic in the communication with the other humans, because we found really, how to say, scaring for the privacy, because you can see when the people turn off the router and go to bed, turn on and go up. Are you at home? Yes, I know that you are at home. Like, no? You can see the, yeah, the host name of the computer or smartphone of other people that are in the house. You can discover parties. You like. And so we are it's the first year that we have these two tools. We are in a moment that we show to the people of the network sometimes, but I think they not already understand completely, which is the power of this view. And so, and I would like that they understand really well, because I think that in a human relationship this can create problems if it's not really clear. And we have also the repository.
Did you say that to see the graph have some problems, social problems?
Perché è molto invasivo della privacy, perché vedi in tempo reale chi c'è in casa con le connettività, se sono in casa, acceso e spento.
You can get the behavior of the users, mapping the connection.
Yes, I know.
E allora l'abbiamo spiegato, dobbiamo farne ancora di incontri, perché non è abbastanza chiaro di che potere si tratta. No? Che i tecnici, le persone tecniche hanno un grosso, cioè è un potere di conoscenza, no? Però è molto nel tessuto umano, e quindi secondo me può portare qualche problema sociale se non è compreso. Ok? C'è anche una responsabilità di privacy anche, no? Delle cose che vedo, deve essermi chiaro che magari alcune cose non le posso ripetere, no? Deve rimanere...
Sono sorpresa perché noi usiamo Grafana alle nostre reti comunitarie, avuto problemi.
Non avete mai avuto problemi?
Adesso non è Grafana visibile per
L'esterno? Ah.
Grafana is not on the view the people of our village because it's not well maintained.
Mm-hmm.
But it was a great tool because people with no technical knowledge can, when it works, to see problems
Mm-hmm.
in real time.
Yeah, I'm totally agree that. Can you repeat your name? Jessica explained that in Altermundi also use the Grafana. No, because I think that we are in streaming. No, explained that also that your community uses Grafana, and I agree that is a useful tool. But I think that focused on the point that technicians need to be in confiance and in trust of the community. Is like in my side is was I was saying yes before. I go on because half hour 25. Okay. The last year we built on page of in the internal network for all the services. The last point that was not visible, but I think is super important is LibreSpeed. Is this because is in the server inside of the network, and I think that it's super useful because people understand that the internal network runs really faster than the external network, and so a LibreSpeed inside facilitate this feeling. So really fast, this is Nextcloud, this is transmission. Okay, Grafana, and our build, our firmware. Now we have a better Grafana. The other was Prometheus. We have a better Grafana dashboard. So we make some idea about what are feminist technologies. We spoke about how we can approach technologies in a different way, and we thought about with the farmers about the stuff that it's true that technology make you faster doing something. For example, the communication or a lot of stuff, but make you dependent from that. And so this is like, okay, we can build a lifter, but not forget the stairs. And it is the same thinking about technology. So yeah, it's okay that we have a mesh network, but not lose the human network that we are. Recognize both. The other part is not do the things alone. Do the thing like we need to do this. It's true that if you do alone, it's faster because you do when you want without take agreement with nobody. But this is useful only the 50% for the community. If you make with someone other, you are doing the stuff in a good way. Like, okay, the base is not that if something is done. The base is that something is done together. Okay, if yeah. We need a testing environment. This is really hard because, in the first moment, sometimes we make experiment on the production, on the network, okay, in production. But this is really bad for the users. Users feel like in something that is moving, and is a bad feeling. So nerds need to not play games. They not play games on the network of our community. Okay. Find the place where you can testing, and this is also useful. Build a testing environment because it's the place where people that are new and so are self-thoughting about network can make experiment without feel bad if they make a mistake. Also, this is important for the server. We are not in this moment at this level to have a testing environment also for the server, but we planned how to do. The good news, that is with automation. Okay. Document everything and explain the choose, and most why not something. Okay, it's important when you explain the choose. We are using LibreMesh, okay? And the important part is, and we choose to not use proprietary software for this. So people can change the choose of LibreMesh, but not going to choose a closed software, a proprietary software. So explain what you excluded in the, and is important because if you give only the choose what is good, not give the hints for new choose after, no? You can change everything. Give time, so go slow. But in this community of farmers, it's quite easy because they are habits to planning in years or in 6 months, and so going seasonally is quite normal. And so the other part is not be too much specialized, and not lost the scope of the community. No, we don't want what we are doing is not developing the best mesh network with the best protocol in the world, but what we are doing is giving a network for a happy group of farmers that they can use. Okay, we take some idea also from Brazil and Mexico. These 3 groups also wrote about mesh network in a feminist perspective. And from Vedetas, we took these Periféricas, Kefir and Vedetas, we took this drawing. And Itachi is the place where they started a mesh network, and they thought about the free software, and so the freedom, the idea of freedom. The community chose the free software for this idea, and mesh network for the shape of the network, and funny, but also and culture. And also and they found these 4 points, that one is intimacy, that is to say privacy, but privacy sometimes we think with the rights of 2 people to speak together without other that heard their conversation, but they say no, privacy is also intimacy of myself. If I have my diary, privacy is have my diary. So I have a place where I can stay alone.
About privacy, what kind of solution are you? About privacy, what kind of solution are you using for the DNSs? Are you using a specific DNS, a bind with a recursion, no, HTTP over DNS?
No, about the DNS, okay, but about the privacy in general is something that we resolve in the level 6, 7, also in the application.
Okay.
And DNS are the DNS managed by the antennas. I don't know, I think so we not use secure DNS.
Okay.
But yeah, it's specific of LibreMesh. Maybe we speak at the end, so I finish.
I can't remember. In LibreMesh there is a default set of DNS, and I can't remember where they.
Not using DNS over HTTPS.
No, I don't think so.
But for example, in HTTPS, yes, you have in the cloud the .pem, the certificate that people download and install in the browser. So are HTTPS, not HTTP. So one is about privacy and consensus, memory and narration. So why we are doing this, the shape of the human relationship and the shape of the network, and memory and culture. Interconnection seeds what means that there are a lot of organization inside of the network, because the network is only it's for communicate, okay? And what do you communicate? For example, the people that make breads use the network to communicate with the other people that make beer, people that move from a town to another. So interconnection seeds is give the right attention, good attention also to the other works that use the network, are interconnected to the network. I don't know if I explained it well, but the network is useful for a lot of activities, and so recognize to the other activities that are part of the network, because they use the network, and so recognize these interconnection seeds. And so the network is because they are, and they are because the network is. And yes, self-management. I took this quote not because I lost a lot in the CCC of the 2019, when someone asked to Moxie Marlin Spike, the developer of Signal, asked why Signal is already using phone number. Do you know that a lot of activists doesn't like that phone number are used in Signal? And he say, we founded a network, and to found a network you need another network. Like looks like a really bad, like an answer to say, not I don't want answer, no? But I find something of true, because for example our network of is like, okay, Moxie say the signal spread because we can access to the contacts of all the activists and spread the contacts over their contacts, okay, without ask consensus, for example, because I installed the signal and this installed just in a second the first time that I used it, because I didn't expect that spamming all my contacts that Andrea is using Signal, okay? I was really scared. But now I'm using Signal, yeah? But yeah, I took that the phrase a network on another network is quite true, because our mesh network was spread by the farmer totally without effort, no? Just putting a node and I. Okay, what are doing these campi aperti means open fields. And are farmers. They make food autonomy, agroecology, use the consensus method. They have a shared warranty about organic. They not use the warranty from the state, from the Italian state about organic. They are in the sense of limits is a concept of the economia solidale and mutualism. So yeah, for example, you can see a poster of zucchine, all different, yeah, because they make also seeds, and from the seeds are all different, and this is a population of zucchine in Creative Commons. Okay, so they are inside, totally 15, thanks. But how much are they? They started in 2003. I think it's not randomly this, because in 2001 in Italy we had the G8, and was the Fuxjäger of coalition of no global people. We have also a big repression, but in that years a lot of organization reacted also. I think so that you see in Italy that last years, that was 2001, there was a lot of 2021 there was a lot of come si dice, anniversary of group that make 20 years old, yeah, because are all organizations that they started less or more in the same period. Are 165 farms, so building, not people, more people, and they have 8 organic market. Go, map of the market. Okay, this is really fast, the consensus method, to say that we not work in unanimity, we are not all agree when we do the stuff. We only ask, we are in the place of consensus, means that the trust is enough to, that you choose the possibility that has not people that is totally contrary, but can take dissensus here, and people that are not agree, but with trust say, okay, we can try, if there are a lot of people of my group that say this, we can try to follow this path. Is a big topic, consensus. Orientation is one of the methods that we use, because I told to you that are 165 farms, and so sometimes the every 2 months meeting are 70 people. So manage a meeting with 70 people is not easy, so we changed, is why I'm speaking about the method, because when also community network grow, you need the methods to take decision together in a way that is not hierarchical and not hierarchy. Okay, we have some shared agreements, so take reports of the meeting, have a timekeeper, have the right to listen, and everyone talks only for herself. In our mesh network community, I was speaking about the meeting of the farmers, okay? And so people was learned by the farmers, the same people, and so mesh network is easier also in this human meeting. We meet all together, the 50 one time a year, but not divided for valley. We have a seasonal one for season tech meeting, and are open. Every month are like a repair cafe, to not only for the antenna, but also to install Linux on the computer, this kind of stuff. We have informal roles for the moment, and different responsibilities. So informal roles, but the responsibility there. This question is about the issue of free software and free people. Okay, but there is in tech, in the nerd stuff, in techie stuff, but for example in the protocols, there is the problem, in the choose of protocol, there is the problem of the informed consensus, okay? To give a consensus, you need to be informed, but for this so specific stuff, how can you be informed? No? And so I'm putting some issues, no? There are the problem of cultural responsibility. For example, in our mesh network, one stuff that we would like to do is a radio, a community radio, in reality a community TV, television. We make we tried with PeerTube. PeerTube is really, wow, it's super. I think that the key feature of PeerTube is the peer-to-peer streaming, in peer-to-peer sharing in streaming. So more than look like YouTube, is really good to use for streaming, because all the people are looking the same streaming, and so they make peer-to-peer sharing. Because if you use PeerTube like YouTube, the peer-to-peer feature, you don't use the peer-to-peer feature. Or it's really difficult. But concentrate to see the same channel, you use a peer-to-peer feature, and it's nice. Free software and free people, the other problem are maintain, optimize, and innovate, because like in this moment we are in the point of maintain and optimize, and so I think that like us technicians, we speak about how to innovate, to put new stuff, no? But in the same moment, new technologies, but in the same moment, like we are speaking of this, planning this, but in the same moment take a lot of time explaining to the other people the other 2 points, no? Like, and so you find all the time in 2 different steps. Like the community is more here, and the tech people are already in another, and so it is strange. Okay, this we tried. We would like became a WISP. It's a long story. It's good because we plan to do in 10 years. And just so because now we are in the point of explain to the people that the second step will be in 10 years, no? Maybe we will arrive to be a WISP if we find the money, if we will be enough, if the law in Italy make possible. So the list of issues for me are the problem of the design together informed. We have not already testing infrastructure completely. The problem of the money, because we have no money, we are paying our infrastructure, not take money from other. Understand a common good, that is difficult sometimes. I find some things, but we are like a shared property of something, because the antenna on the roof are of the people. Like on my roof there is my antenna. So I own something, but own something it's not useful only one. Yeah, I can do nothing with one. No, it's working only if there is another. No, so it's strange because so there is a common good and a private property working together, a multi-private property. And we are to develop a policy of service and content. Yeah. Okay, this is the new of this summer, that I spoke to you about the movement of hack meeting. In Italy that is a movement of radical tech people about free software, hack meeting, not only in Italy. Exists also Genuino Clandestino. Genuino Clandestino is the network of radical farmers in Italy. So there are from Sardinia, from Sicilia, Toscana, Lazio, Marche, every region. And it is strange that in the last 5 years we meet sometimes, you recognize, hey, but in Genuino Clandestino you find people, but I see you in a meeting. And sometimes you are in a meeting and then find the people and, but you grow vegetables. And so there is a big exchange. Also, the last year, we wrote a text, a magazine, an article in a magazine about license, open license on the seeds. And so started a bit of research, and after arrived other people that have a project about mycorrhizae, mushroom, compost. So a lot of technical stuff for a small for a small farm. Not big, people that exit from the university, and in the idea of the university, you have to go to work for the big tech. Okay, also also for informatic people is like this, no? But also in agrology, and so we are started to speak about this because the reality is built from a lot of public fund money that give to proprietary software and give to big industrial of agronomy. Okay, and so we started to speak this that okay, now we need to find some strategy to that the public money not go more to develop this kind of huge powers, but going in more fragmentation groups, because this idea started from the construction of the price of the vegetables, because a lot of organic vegetables, people say, hey, but this cost a lot. Yeah, and this zucchini, cost a lot because there is not developing of techniques to have easier zucchini in agro-ecological way, no? Like the price of a lot of vegetables of the agro-industrial is really low because we paid the research. No, there is like a hidden, we like the people, no? There is an hidden price that was the research. And so it's really, okay, I think so that you keep what I would like to say. So it's the same for agro-ecological, they need help for the research. Ho finito? Yeah. Two minutes for the question.
Very quick questions.
How was the internet deployed in your valleys before you started with the mesh network? So did all the inhabitants had a DSL connection or whatever, or was there just no internet connection and this was the first time they got internet in their households?
Okay, I don't understand well your question. Can you?
Se avevano già la connessione o no?
Ah, okay. No, there was not a connection, and also phone. Okay, there is not. There was a connection, wired connection, but when raining, not work because there was a wired connection that was built by the state, the Italian state in the 70s, and now when it was public. So now everything is privatized, and the private company. If you ask him, we are your user, where are you? We are 50 kilometers from Bologna, we are in nowhere. So, and also the phone not working well, so also the connection.
I think for the audience, you can imagine what she explaining to you, something like the rural part of the United States, when there is nothing giving connection except for all the infrastructure run by only one provider that is asking you a lot of money for crappy connection. She is describing the same condition.
Yeah, there are also WISP. And for example, 2 contracts of the 4 contracts we have with WISP that is inside of mailing list of Linux. And for example, in the contract is written that you can share your connection with your neighbors. So like it's legal what we are doing, and it's rare. Because that is rare that WISP raro. Sì, thanks.
This is against the law, we tell you just to use on the ground to share your connection with a neighbor. Because sometimes it's written in the contract that the connection is only you can only use the connection in your apartment or in your unit. You cannot share it.
Yes.
Just to give you some background, because this is something that all I in Italy can easily understand, but maybe in other new tradition, there are this kind of limit of the consciousness.
Okay, and this WISP accept sharing because of you or because the WISP like the idea?
They like the idea.
You didn't talk to...
Yeah, I need these people of the WISP because it was in the mailing list of Linux. I also asked why you like a mesh network, you like help another mesh network as a commercial entity, and say that there is not damage. Also, we are cover places that was not possible to cover for them, so it's super nice. And the other is super beautiful stuff that say that when they started, would like have people that shared experience like in Linux mailing list, and so recognized that took a lot, and looks and is happy to give back the experience. And the other super beautiful stuff that say was that thinking to give their WISP in the future to someone because they became old or I don't know, would like that will exist some community, some idea that the people association can run a network and so sell to the user instead of sell to someone bigger. A lot of stuff. No, wow.
Yes. I wanted to congratulate you.
Thanks.
Yeah, I really like what you're doing. And actually, for our network, to explain, so we have also a mesh network, wireless network, and to explain the system, how is the relation between people, we say that it's similar to the relation you can have between farmers and people, where you can buy vegetable directly from the farmers and don't go to the supermarket. So we have this in France since a long time. So it's called AMAP, but I think, you know. And so we say, this is like this, but for internet. Okay.
Yes.
But you did even one step further. That it's the same system that you implemented. So it's very nice.
Thanks.
What is the acceptance of people for this internal services you described, like this PeerTube and so on? I think when we would do something like that in Berlin, I think no one would really care because everyone just wants to use internet. From my view.
Ho capito che dici che è interessante.
Acceptance rate. Acceptance like they didn't like the services.
Do they use it?
Non ho capito.
If they use the services. Se usano i servizi.
Non usavano il servizio?
No. La domanda, se usavano i servizi perché nella sua community non usano i servizi perché solo gli interessava internet.
And after, there is a tool. But what do you think about a television? So, and in the imaginary worked, but I think so that we will spend the time before arrive to have really a television, a PeerTube television in the valley. So it's only really prototypal. And about the services, for example, yes, not a lot, but yes, for example, the cloud. But cloud and torrent are the two services for humans, like the other are more for technicians, no? And they use when on a Saturday when the network is low in the internet and the internal no, and so they see video. But Nextcloud is quite bad to see video, because if it's not change the format of the video to ceiling streaming, a lot of time if .avi
Connected.
Gel- oh.
Do you have some fun?
So,
Just to give some background about what we experienced in Linux 4 or 5 years ago, maybe more. One of the problem when you
Enough for today. Yeah, okay, cool. Yeah, okay, cool. Then let's do that.
Yeah, after your talk, I think we can.
Was this it? Yes. Okay. This is. Can you hear me, guys? Yes.
just about 2 Wi-Fi 6 access points. Change them again.
So okay. Yeah. How do I do this? Yeah, like this. Yeah. Okay. Okay. This is the last one for today. It's gonna be a short one, so not 30 minutes or something. Maybe a couple of minutes, just about what is Wi-Fi 7 about. It's far less thrilling than the previous talk, I'm afraid, because I just agreed to do this talk because somebody pressured me. But yeah, if you really want to know, if you're interested in how Wi-Fi gear in 2 or 3 years, or what it can do in 2 or 3 years from now, what is the link bandwidth that will be available in these devices in 2 or 3 years from now? Yeah, I talk a little bit about that. So Wi-Fi 7 is the coming generation. This is being standardized right now. You cannot buy this. Yeah, Wi-Fi 7. I will try to make you understand that they changed the naming thing. So previous, we remember that if we were talking about 802.11a, 802.11g, and these alphabet soups. I don't know, has anyone ever heard a reasonable explanation why and how they come up with these names? So why do you choose it A, why G, why B? Huh?
Most of the letters in between also exist.
Okay.
But they are not.
Oh yeah, sorry. Right.
So with 802.11, and that's the working group, and then for each standard they use a different letter, and also the letters between mostly exist. So I think some were left out, but most of them exist. So at least there's
it's a systematic way of
they do
choosing.
A, B, C, D,
Okay.
E, and when they were Z, they started with AA.
Okay, but we only know a couple of combinations. Like this is something that.
Yeah, this is for fire rate and all of this stuff. But you have, for example, the H. I think that's for QoS stuff and such things.
But
So 802.11h, and there are a lot of things. Wikipedia has a Wikipedia has their list where you can, at least for the first, I don't know, 20 letters more or less, they have the.
And there will be some .11ZZ at some point in time, something like that.
Maybe.
Okay. So anyway,
I don't know when it's probably in this AAA.
Yeah. Anyway, it seems that this Wi-Fi Alliance, which is sort of an industry non-profit, come together in order to increase interoperability, was born much later than the standards family. They sort of made up their mind and thought about let's make it more consumer friendly and call it generational wise. So like in the cellular world, like 3G, 4G, 5G, 6G, whatever G. And now, yeah, we are supposed to use these numbers. And I guess it's a good idea because it's easier to remember. Currently, you can buy generation 6 gear. Generation 7 will be on the market around 2024, I think, something like that. And what is the real difference to the previous generation? Actually, it's quite boring because all that keeps being really significantly changed is the link rates. So the sort of the channel widths, if you want to, the channel widths. We started with 20 megahertz and now we are at 160 megahertz, and I think BE is supposed to even double that to 320. So they're just doubling and doubling and doubling. It's really crazy. If you look at Moore's law and these it's related to Moore's law. The number of transistors we can cram into an area, and the cost of manufacturing is still going down, down, down. I just looked up. I mean, it was an Intel website, but they said now we're entering the Angstrom area. So we were in the nanometer area already, and now we're going into the Angstrom. So it's really kind of does not seem to stop anytime soon. So this goes up. The number of antennas goes up. It's still OFDM. Everything else, so the principles are the same. So we can expect to have devices with 16 antennas. They're all transmitting simultaneously, which is kind of funny looking, I guess, in the future. Like, so this is the boring part. It all keeps doubling. In 2 years, we can buy this. This is another way to show that over time. So over the last 40 years. This has been going like that, so it's a pretty straightforward evolution. We seem to be better at miniaturizing and making things even cheaper, also for the next couple of years. So, who is familiar with the concepts of MIMO? MIMO, a couple. So maybe I say a little bit about it. So my background is electrical engineering. I did my master thesis on coding in MIMO systems. So it means that you have not one transmit path and one receive path. You have multiple of them on both sides of the link. So it's expensive, but as I said, Moore's law makes this stuff cheaper and cheaper and cheaper and cheaper and more power efficient. So we can cram more and more of those paths into one device, and they transmit and receive simultaneously, and with some really intricate math you can then sort of multiply the link bandwidth. It's maybe important to say that this is not as sort of, you cannot cram more and more chains into each side when we are talking about directional links. Then it's kind of limited to more or less 2 or 3 chains that make sense to have, as far as I know. So this is these 16 antenna devices. These will be the devices that will be covering football stadiums, large areas. This is not supposed to be used in directional links. Sure, interject. I may be talking shit, so please.
It's not shit. It's a question about MIMO, because I understood the concept of having multiple radio working at the same time and using the same access channel.
Yes.
But two things. Since we are in a CDMA access system, it's not possible to actually transmit all simultaneously at the same time.
What do you mean with CDMA?
Carrier detected multiple access.
Oh, okay, yeah.
Mm-hmm. It's theoretically impossible because we are still stuck with the CDMA model. So how it's actually working like that? So it's used for the beamforming to have to detect where the multiple devices are and find the correct radio to talk with the device, mm-hmm. or is like talking transmitting the same signal from multiple radio to increase the chance to deliver it to the destination.
Yeah, it's both. I mean, it's there is beamforming going on, and there is this simultaneous transmission. But it's not the same signal. These are phase-shifted permutations that are being sent, and the end result. I mean, this is really matrix mathematics all the time. Yeah? If the channel with several inputs and several outputs, yeah, has a certain mathematical property, then you can transmit multiple times, even with CDMA. So this is when I learned this was also quite fascinating. But yeah, shit works. This stuff really works. The channel has to have this certain property. That's why I said it. It's in directional links. The channel does not have that property, and that's why it doesn't work for directional.
It's magic with mathematical
It's
magic.
magic.
It's magic and mathematical physical magic.
It's a statistical property of the channel is used. Oops. So, yeah. Okay. Yes.
You always talk about CDMA, but didn't 802.11ax switch to something like listen before talk and then do an OFDMA? So it's not really CDMA anymore.
What? Say again? Because OFDMA is the encoding, it's not channel access. Now
Yeah, but you can assign resource blocks for different stations, and so basically the clients are not using any more CDMA, or not sure.
I think they still are, but these what you mean assigning resource blocks to different stations? This is definitely also in there in the so this is being put in there even more and more. This degree of freedom, but I think this carrier sensing in terms of is the channel being accessed right now? So is the power there or not? This is still the basic channel access principle, as far as I know.
CDMA, CSMA, two different things. I think CDMA was just mentioned in error. I think we're talking about
code division,
CSMA.
multiple accesses.
Right, because this was the 3G
but we're talking about
style
carrier sensing.
modulation. Mm-hmm.
Yeah, we're the medium access. Have I cleared something up? No, probably not. Yeah, we're mixing a little bit the channel access and the encoding here. Anyway, MIMO is magic stuff, kind of. You can do different things with it. So you can either direct the energy, or you can look for diversity here. It's been some time since I talked about this. I don't know if this is all. So take it with a grain of salt, please. Then there is this thing that you can address with these MIMO tricks, more or less, several stations at the same time. So you transmit a specifically coded signal, and they all get some kind of benefit from this transmission. So it's not like before, where you serve one station and then the next and then the next and next. This is really multi-user MIMO. But this was also there, or it was in the specification of AC. So this is Wi-Fi 5 already. So this is getting even more and more and more in the next generation. The degrees of freedom, how you assign the resource blocks, so which station is served on which particular subcarrier frequency at which particular time. So if we imagine the channel as something that sort of has time slots and has subcarrier slots, then each of these blocks can be assigned to different stations, more or less. So this freedom that one station, next station, next station, next station is completely enhanced, depending on if the channel is changing temporarily in the sense that sometimes this station, we're making use of even more degrees of freedom in how we make use of the channel. That's the short version of it. And
so in Wi-Fi 6 is more like a mix between time access and client access, because multiple clients are served at the same time on different subcarrier slots.
Yeah.
So it's not time division and it's not access division.
Yeah, it's getting hybridized and mixed and even more degrees of freedom all the time. So this is a consequence of the algorithms being implemented. They can be very complex in optimizing. So they measure the channel, and then they find they try to find optimal solutions and how to assign these resource blocks. It's very in LTE or so. It's also talking about resource blocks all the time. So this is familiar from the cellular world.
Soon we will have more processing power in the Wi-Fi subchips and in the CPU.
Yeah. So basically, yeah, it marches on. This is, I don't know if you can read this. This is just the generations again at the glance, where you can see here the link bandwidth. It triples here. It more than doubles here. It more than quadruples here. So this is crazy stuff. Of course, security is also improved. So we have WPA3 now. As I said, 320 megahertz in the future. I don't crazy. Yeah, a link rate of 46 gigabits per second. It's crazy. One thing is here is Wi-Fi 6E. If you see it, it means that it's the mode 6, but used on 6 gigahertz channels. This is the allocation that I found. So this is interesting stuff. Here in the EU, it's just this block here, the UNII5 band. But still, yeah. So we have even more spectrum to use, which I always like. So, as a short summary, maybe this is also too technical, I guess. So, bandwidth is going up, antenna numbers is going up, the encoding resolution is going up, and then there are a couple of sort of technical, intricate, interesting for nerds features that are also being added. This is hybrid RRQ, which means it's a more efficient way to rebroadcast. Then we have multi-link operation, which means if you have like a 5 gigahertz radio, a 6 gigahertz radio, and maybe another one, you can sort of bundle them up on the second layer, I think. So they can act like one big fat pipe. This is also there, and which is probably more important for our cause here. There's supposed to be some features in there that allow access points to talk to each other when they are sharing a common environment. So there is to be some inter-access point communication being standardized in Wi-Fi 7. But I did not really find too much specific info. There are just a couple of papers where the ideas are proposed, and I find them not so. I mean, there's a master and the slave role then, so a master access point tells the slave access point what to do, and somehow they can come up with a selection of who will be the master. It's not rocket science. Yeah, if you press me hard, I will look into that further in the next few days, because yeah, it's still maybe interesting for us here. Maybe there's some meshy parts in there even we can imagine. So I said this. I think I can cut it short. This is again a sort of the menu of kind of coordination techniques they want to put in there that allow access points to sort of collaborate and collectively act. So they collaboratively do the channel sounding or do coordinated OFDMA, coordinated beamforming. So all kinds of really, really intricate things are being proposed here. Let's see if we will be able to use them in a couple of years. But the message is, it's getting faster, it's getting more efficient, it's getting still cheaper. Yeah, and yeah, I think I'm done here. So maybe you have a question or two, but otherwise, thanks for listening. These are the two references they have 150 references each, so they cite quite a lot of material if you look that up. Okay.
Maybe only one thing that you missed in the difference between Wi-Fi 5 and Wi-Fi 6 is the uplink capability of the clients. On the Wi-Fi 6 you have a cap on the speed of the clients through the IP. So you can have a good downlink, but there are some limit on the bandwidth on the uplink. In the Wi-Fi 6 it's changed, basically it's symmetrical, so clients can have the full bandwidth in the multiple in the MAU MIMO environment. There was some limitation in the Wi-Fi 6 because the MIMO was added later, so only the clients were capable of getting from the access point the full capability, but the transmission was not using the MIMO. In the Wi-Fi 6, MIMO is used on both ways because they upgraded the radio, and that would mean that you can have 1 gigabit on a full duplex with Wi-Fi 6.
Yeah. There's one, there's two.
What about obstacle penetration? Are there some experiments like penetrating a wall, something like this? Because if we are raising the bandwidth and we are changing the channel, probably bypassing a wall could be more tough for the Wi-Fi. Is there anything there?
I haven't seen yet.
Does it work from my kitchen, from my living room, let me say?
Yeah, I'm not aware of anything in that area yet, but
I think the usual thing is that you need a certain SNR for the better, more efficient modulations to work correctly. I suppose this hasn't changed because it's almost a physical law, I guess. I don't think that you can do 4K QAM when the reception is very bad and the noise level is very high. This is pretty much to what we've seen Wi-Fi already, so where you just switch down the MCS, and then you get worse modulation. Physically, I don't think that anything changes in terms of penetration of the waves themselves.
Yeah.
2.4 gigahertz. If you move which bandwidth you're using right now, we're using a higher bandwidth that probably we will experiment more.
I've done some testing at home because I had a couple of. I've done some testing at home because I have a couple of Wi-Fi 6 access point. Basically, switching from the 2.4 is the best one. Work everywhere. You can Wi-Fi whatever, 1.5 gigahertz. When you use the 160 channel, remember the power. The power is splitted on the channel. More is the width, less is the power of the transmission, because the power is splitted by ARP limits across the whole channel.
Yeah.
So increasing the width of the channel, it's what I was logging before, will mean that you have less and less power available to transmit.
Yeah.
So even because right now with 160, 2 access point using a wireless uplink get something like they call 50%, but it's around 70, 80 dBm, 2 volts on 5 gigahertz, and there are 2 access point. The clients, so mobile phone, whatever you're using, you're gonna get a full 160 outside the room. So that is the reason they are increasing, but the idea is to having the same device in the same room connected. So you will need 1 access point for each room if you want the full capabilities.
Yeah.
And I'm expecting if they double again the 160, you have 2 problems: the power limit going even lower and the noise. Because even with 160, you have to go up in the bandwidth to find a clear space. With a 320 bandwidth, I'm scared of that.
Yeah. This is
Not
for
only
very
line of
short
sight.
distances, line of sight stuff.
Yeah, 5 gigahertz was 10 years ago good because the normal carrier owned router that you have at home, they only had 2.4. Now everything is transmitting on 5 gigahertz. So if you like in a condo, is impossible to have a clear signal.
6 gigahertz is now there.
Yeah, but normally he said a really good thing is getting cheaper. So when something gets cheaper, the provider will tell you this is the new fastest, best router in the world. You will have for free at home if you choose me. And that router will have a crap implementation of Wi-Fi 6 that is really shitty and only make noise in your environment.
Yeah. Another one?
Can you maybe sketch the idea behind this multi-IP coordination stuff? Because I don't understand it really, how it will work. Does it work via an Ethernet backbone? And for me, it quite sounds that maybe for this feature you will need APs from the same vendor. It looks like a bit like a vendor login, or is there interoperability between the devices? I have no idea.
Yeah, I totally agree. I mean, if they do a decent job and standardize it thoroughly, the vendor login problem should not kick in that hard, I guess. So I hope, but it's still, I think, yeah, I have seen these proposals in previous generations and it's not coming to fruition. So most are using proprietary cloud coordinated yada yada thingy. So this is it's not standardized what happens out there right now. So they're trying to change it. Maybe they succeed this time, but I have no high hopes.
But what's the function? Is it that multiple APs can then decode the same frame that was sent from a client, like a big antenna array or whatever? Or I have no idea what's the function at the end of having multiple APs.
I cannot really tell. I look if you look at these two references and specific the papers that talk about this, it's very hand wavy. Yeah, it's yeah, maybe this, maybe that. I mean, in principle, they can go very far with the coordination if this coordination is really tight and stuff. I see the problem more in that if this whole coordination is based on a hierarchical principle again, that you have that there needs to be always one privileged access point that tells the others what to do, so follow the leader principles, then I think it's a kind of, for example, then the whole problem pops up that is in unlicensed spectrum all the time, that when another installation nearby also elects its master, and then there you have, I mean, yeah, it's I think this is vaporware actually. I don't think this will become reality too soon. I think they put it in there. It's this coordination aspects have been in there in AC already, if I remember somehow. So I think the vendors, they want to do their proprietary, they want to push their proprietary coordination things and have a low interest in making this happen, as far as I understand. So I'm a bit skeptic.
So will it be a bit like LTE? What's LTE doing currently?
LTE in the sense of?
I think they have also like functions for multiple antennas, but I'm not sure.
I think in LTE it's a bit different because it's a licensed spectrum. So you have one license holder. That license holder wants to really maximize the benefit he gets out of this resource that he bought. So there's a different incentive to make coordination happen there. I think that's my understanding. And also in LTE the cell distances are larger, so it makes it's more efficient, it's more useful there. Okay.
Yeah, do you have an overview what is actually implemented or what will be implemented? So for example, we saw where with Wi-Fi 6 also more or less 2 generations, so the first gen and the second gen from mostly all of the vendors. Not the second gen, not only adding this Wi-Fi 6E, but other stuff too. Do you have there an overview?
No, I'm sorry.
Okay.
Sorry. But if you look at one of these two papers, it's full of references that maybe contain an info about it. But maybe you know more than, or Marek knows more. I have no overview on this. What's getting actually implemented and be used in there.
I don't have an overview.
Yeah, me too. Someone has one? Okay, I think we're done. One last joke. I heard from someone who said that whatever happens, the really important thing is that the number, like currently we are using generation 6, that number needs to always stay one higher than the cellular number. So when they come with 6G, we have to have 7G. So I don't know if there's any truth to that story, but I like that.
As long as they don't copy it from the USB. The numbering.
Does Wi-Fi 6E has a known 802.11x name? 802.11?
I don't know. Sorry, I'm out of knowledge here. 6E you were asking? Yeah. No. Could. Yeah. Maybe someone should check. Yeah.
But I think also for different
channels may have for different bands. They have
No,
different
no.
standards.
It's in the slide before. The channels are the same.
Or maybe it's already an AX.
It's AX, but
Yeah.
with different channels.
Yeah.
With different bands. The channels are always 20, 40, 80, and 160.
I assume that there's a standard which defines from IEEE some 80,
Yeah.
802.11 something is where it's defined. Maybe it's
Yeah.
part of AX already.
Yeah. Sure. I guess so too.
Should be the case,
Yes.
It's only you seen the slide in your slide before was only the bandwidth because the channels are the same since the technology is the same.
This one?
Like before. Here. Watch down. Only the here. Only the if you see Wi-Fi 6 and share the same things except for the channels.
Yeah.
The bandwidth.
So Wikipedia says it's part of the AX.
AX. Okay, cool. Now we have. Thanks for that info.
Wikipedia,
6.
so-
Yeah, 6. Yeah,
Also
that's.
your slides say the same. You see. It's
Okay. Yeah.
in the middle.
Yeah. Right. Cool. So, thanks for listening again. And next up is our first social event, right? So it's 8:30. 8:30, and where do we meet?
At the pizzeria.
Ah, yeah. Yo. This is not a perfect. Do you want this or this? Yeah, this is better.
The perfect segue.
Come on, dude.